All right. Happy holidays, everybody. Let's put start soon up there so people know. And then we got to get this thing popping. Get YouTube chat up because there's probably already somebody that said something. I just wolfed down a sandwich, so I'm going to be a little burpy. Be a little irpy at first. Let's go to YouTube. Oh bother VOD. I got like a goth hairstyle, like over one eye. Open this up, this economy, and then we can get this popped out. There we go. Close that. Now we should have. Hey, see, I told you this is already chatter. What's up, Madam You? How you doing? Good to see you. Good to see you. Good to see you. Put her there. Put her there. I just want to shake his hand. Let's see. We got that with my pooping message up, and then we got Twitch over here in case I need to moderate. A new PCB in this economy? Madness. We're all full of madness. Okay, so apart from what we're working on today, I'm actually going to be redoing my computer soon, and I don't know to what extent, how crazy that's going to be for like whether or not I'll be doing stuff on stream with it. But what I want to do is I want to move my computer from. Let's see, can I show that? Yeah, there's just a paper plate over there if you guys will tolerate it. The PC here is this thing. This is the reason why I can do the new PC project, because this Legion Go, this will run basically any game that we're going to want to LAN. You know, when we get together and we play stupid computer games, we play like low fidelity kind of games. You know, abiotic factor is not all that much of a stress on a PC. So this thing being gaming hardware in sort of a pseudo laptop form, perfect, right? I'm going to be using this also for 3D scanning as opposed to the old laptop that a family friend gave to me. This thing is very slow. This is good for scanning cars, although this thing could probably do that job, but I'm going to keep this as the car scanning laptop. It'll remain unupdated or changed in any way, shape, or form. But anyway, this is the new gaming rig for traveling. This is the old gaming rig over here. This, I would like to put in a rack shelf and finally give it a 1,000-watt power supply. So I have a 1,000-watt power supply here. I am not going to be repinning anything. I'm just going to plug it directly in. The question is, can I fit the rest of the computer in this space? Or do I need to get a different rack panel? I could probably stand this up and put it in the corner, and that'll give me a lot more room for the rest of the PC here. I would love to keep it in all the Maker Beam stuff too, and then put a reservoir up high so that the bubbles don't collect in all of the radiators and stuff. I'm not sure if I can really pull that off. I could do radiators on the back, venting backwards. I could sling them underneath. I don't know. There's a lot to be figured out on that. I got to put this aside though, because it's taking up my chair. It's in my way. Extra cables. Let's go over there. This stuff can move. This is my Legion Go test area. I need to plug it into this monitor and get it running games with a keyboard and mouse and see how it is, because I just ran it regularly. But yeah, that's the idea, is that I would like to get my PC to actually finally have its full 1,000 watts available to it. Because the 6900 XT and the 5950X require boost power. So they don't really use more than 750 watts of power, except occasionally they like to lean on that extra amperage to do some heavy computing in a pinch. Is YouTube comments, are they showing up? They should be. Oh yeah, because it's just the Madam UA from 1,000 years ago. All right, we're gonna need calipers. We're not gonna need a knife. The mixer circuit can just kind of stay over here and stay out of my way. Speakers can move back a little bit. We're going to be doing a little bit of measuring and stuff. I'm not quite sure what I've bitten off here. if I can really chew with the big leagues. So let me grab my keyboard, my old keyboard. We have the new keyboard that's also broken. It's the quote-unquote backup keyboard. So here's this one. Get this out of the way. This is kind of an important part. I only have one of those. I'll have to order more as we get through the mixer. I was thinking with the mixer, I'm having a bit of trouble fitting everything. So this is why we're doing this today, is because I have kind of like a writer's block for the mixer, and I'm thinking like maybe I want to have a version of the mixer where you can put in a CV and control it with that. Because, like, you know, maybe you've got 2 banks on your synthesizer and you want to put an LFO that's, you know, timed with everything to flip between 2 different sort of refrains, I guess. I don't know. Putting it over to CV would mean adding another rack unit next to it, right? It would be, actually, it would be this wide. It would be as wide as this thing right here. Except if you don't want the CVs, you can crack the board apart and use headers to put them back to back. So I would have 2 boards right next to each other with routed out center, and then traces going across that would break when you break the 2 boards, and then those traces that go across would also be going to vertical headers. So you break the board, put it vertical, and now you've got your tiny minimalistic mixer that's manual. Whereas if you have them side by side, I could have a CV that would crossfade between the 2 channels. Because that would be that extra op amp. There's 1 extra op amp on the board. And so what I would do is take in CV, which is plus minus 5 volts, and I would take that plus minus 5 volts and apply it to 1 channel, and then I would put that also to the inverting op amp, that unity gain inverting op amp, and that would invert it for the other channel. So you'd be fading between the 2 channels. Although, how would I... There would need to be a jumper setting for that, and it might invalidate the volume control. That's a totally separate control, actually, to be honest. What's up, Remdog Cap? How you doing? How would that work? Wait a minute. It would take over what the knobs are doing. Or it would add or subtract to what the knobs are doing. Maybe that doesn't work. Hold on. Scratchy. Scratchy, scratchy. How would that circuit work with everything else? I guess I'd need to test it. I would need to test it. But that would be the idea would be, if you buy this thing as a kit, right, I would do all the surface mount parts, but then the user would be responsible for soldering the through-hole stuff. And in doing so, they can decide whether or not they want to snap the board and put it back to back, or whether or not they wanted CV crossfader input. I think that would be kind of interesting. I mean, the big question is, how do I fit everything on this board? This board is already super duper space restrictive. So, oh, speaking of which, I actually have to find documentation. We have to find the documentation for the keyboard project, the QMK project. How's everybody doing? I hope everybody had a good holiday. Quiet on Twitch today. Hopefully people will be like, man, I'm bored. What's going on today? And they'll open up Twitch because they just have to avoid socializing with their family. I'm like done socializing. I'm so done. I've reached my limit of patience for other people. Not to say that I didn't have a good time. Saw a lot of people. All right, so what would it be called? A keyboard project? Would it be an archive? E, F, G, H, I, J, K. Keyboard overhaul. There it is. Cool. All right, so we got key map stuff, we got matrix stuff, and then we have a DXF. What is that about? Code tenkeyless. Edit with paint. Oh my God, there's so many programs. Yeah, here we go. I like tenkeyless. What, you don't like tenkeyless? I like tenkeyless. The key mapping on this is insane. This is the working document for the code tenkeyless takeover of the keyboard. And so I'm hoping to commit this to actual PCB, but it's fairly complicated. $1,898 key, 96% forever. Look, I don't use the numpad. Even when I worked retail, I didn't use the numpad. I used the numbers above the letters. I never understood the redundancy. I know people say it's fast, but if you learn the other ones, it's fine. Oh, Gonad gave me a shout out 3 days ago. That didn't cause any follows. I think Gonad in my audience is pretty what do you call it, locked in at this point. I don't think we're going to be spreading the love by shouting each other out, but it's very nice of him to do so. So yeah, this is what we did to my keyboard, and we got to kind of like double back on it and figure out what exactly is connected where. I have muxes, three muxes, three Maxim muxes. They don't have to be Maxim. The Maxims are kind of slow, and they're better for analog stuff, but it's just what I had. And maybe we could plan on buying an actual mux chip that's compatible with the Maxims, that's faster for digital stuff, because this is certainly, it's not the best solution. It's just something that worked. It barely works fast enough. Although my keyboard has been perfectly fine for quite some time. We're going to take it apart today, though, and we're gonna take a look at some of the craftsmanship that I did on this thing and evaluate whether or not we can actually build an orange flexi PCB that'll go in the place of my own crazy soldering job, because I would very much like that. And then who are we building it with? We're building it with JLC PCB. JLC PCB. I found somebody who offered a design rule file for JLC, although I'm not sure how, here you go. I'm not totally sure how old it is and whether or not it applies to the modern standard, or if JLC updated their stuff or not. 2-layer flexi, 100 by 100 millimeter, $2. $2. What the hell is that all about? So hopefully we can make it fit within 100 by 100 millimeters. We'll have to assess that as well. I'm thinking that it can basically, it'll just go in instead of the, what do you call it? Instead of the processor, the main processor. There we go. We got there. We got there. PTFE. Rogers. Who the hell's Roger? Low dissipation factor, solid dimensional stability, high frequency applications. Oh, neat. Luckily, we're not doing anything like that. Copper core. Aluminum. How much is aluminum? $4. What about Roger? $95. Well, that's not that bad. $79 special offer, and then surface finish is $16. PTFE, Teflon, $47. These are very reasonable prices. Yeah, this should be pretty cool. I have absolutely no idea what Rogers is. Apparently it's for high frequency applications, and they show an example of like a high frequency board that has, the cool thing about PCBs and components and stuff is when you get up to RF frequencies, you can build a capacitor by just putting a ground plane near your trace. And so you can make these flare outs and stuff, and those will be like capacitors and resistors and inductors. It's really weird stuff. And I at one point I found a guide that explains all of that, and then I lost the guide, and I've never been able to find it again. There was a beautiful like website, and it was like Web 2.0, Web 1.0 actually. It was just like a normal old website. It was kind of like the radio, the antenna guide that I love, but it explained all of these different forms of component that you can build in by just shaping your traces. We don't do anything nearly that high frequency though. Lucky for us. I can't even imagine the stipulations that you have to follow when designing an RF PCB in the way that we do. Some traces are without FR4. Oh, that's mad. That's madness. That's madness. I guess that's what that white substrate is. It's beyond my reasoning. I do not know. I ain't that good at this stuff. No, we're going with flexi-pcb, which if we had a design ready, it would only be $2 today. The white is no substrate at all. So wait, these are floating traces? I thought white would be like a plastic. What is a Rogers PCB? Electronics. Low dielectric constant, less noise, dimensional stability, uniform material structure. Oh, I was hoping for pretty pictures, but high performance printed circuit board substrate material that's made by laminating multiple layers of specialized materials. The material is named after the Rogers Corporation, which is the leading manufacturer of high performance engineered material. Rogers PCB materials are commonly used in high frequency and high speed applications where signal integrity, thermal management, and reliability are critical. Some of the key features of Rogers include low dielectric constant, so it's a different material than FR4, low loss tangent, high thermal conductivity, dimensional stability, and uniform material structure. Neat. So it's an alternative to FR4. Very well controlled PCB substrate with low frequency losses, but it's a brand name. Yeah. So they got a hell of a market there. That's what I was looking for. I want pretty pictures. I want pictures of Spider-Man. That looks like a normal PCB. That's a satellite. They're wiggling the PCB. Oh my God, it exploded. Well, their pictures aren't doing a really good job of explaining it, but I guess Rogers makes some special sauce that they can mount parts to, and it allows you to have better substrate. We're not doing that. We're doing a 2-layer flexi-pcb, which shouldn't be all that hard to do. It's just we need to figure out how to wrestle Fusion 360 into mechanically putting all the stuff in the right place. That's going to be the challenge. We'll get there. We'll get all our ducks in a row basically today. Let's start up Fusion, because that's probably going to be a beast to start up. Fuss, enter. I got it. So I finally got my meds again. I'm finally off of the executive slump that I was on, and I made the mistake of taking one late in the afternoon yesterday, and it's a long acting, and so I ended up playing Abiotic Factor. I'm still playing it. I'm still having fun with that game. But I ended up playing a bunch of Abiotic Factor and then falling asleep at my desk until 5 a.m. So while I do feel well rested, I got to be careful about going a little too crazy. But I'm back, and I'm getting back in my good habits again. So I'll be able to get a lot more done. Incredimike, subbing for 4 months. Thank you, Incredimike. Really appreciate that very much. Happy holidays to you. Happy New Year. How long do we have until the New Year? 3 days-ish? You ever worked with T-slot aluminum extrusion? Have I ever worked with T-slot aluminum extrusion? No. It's like one of the primary building materials here. Not T-slot though. I use 2020 and 8020 products. 2020 is much cheaper, and it's probably what I'm going to be using from now on. But like, the board over there is made with Maker Beam, which is also not T-slot necessarily, but it is aluminum extrusion. I use it a lot. I use it a ton. I built a whole computer out of it. That's the computer that's sitting behind me. It is great stuff. It's expensive. It gets expensive. Yeah, I guess it is a type of T-slot. I don't know. It uses those T-slot nuts, but they like to call it their own product. But 2020 is so much easier and cheaper. I even bought a bandsaw blade that would be able to cut the stuff cleanly. It's not as clean as getting it from the factory cut to your specific specifications, but having the chop saw, the expensive chop saw with the right blade in it, is really, really nice. Why did Fusion forget all of my preferences? Why for are you? Does it need to update? Just tell us right now. Please. It didn't include the layout grid, and then it forgot my visual style, my environment, that's River Rubicon. There we go, so we don't blast out people's eyes. I'm not sure where dark mode went. I thought we were getting dark mode. I'm gonna take a look at my settings real quick. Preferences. General. Usually used for several gigahertz and up. Yeah, so like real hardcore. Full Rogers stack ups. Isn't that like a sex position? Are not really that common. You usually have the first and last dielectric layers and everything else can still be FR4. Weird. So the product is so expensive that you're not making your whole circuit board out of it. And likely FR4 is tougher in some way. Tool tips, reverse zoom direction. Documents, graphic driver. Yeah, why don't we just auto select that one? Space mouse driver. Start fusion in design, that's fine. Hang detection, nah. Command prompt, default measure, fusion team notification. And then those are zoom settings. Graphics, display. No, that's fine. Graphics, normal, normal, normal. Wood bump. I guess they haven't pushed the version yet. Yeah, nothing about dark mode. Count, preferences, sign out. What's over here? View. No, none of that. Save new drawing. Okay, all right. So we don't have those settings. I don't have dark mode yet. Do you have a space mouse? I do. It's just not plugged in. Space mice generally just collect dust. I spent like $100 on that crap, and I used it a little bit, just a little bit. You know, it's kind of fun to be able to zoom around your drawings and, you know, have a more natural kind of view of it. But in the end, my right hand, instead of operating a mouse that has 2 buttons on it, is much better spent at the keyboard. It just does more work that way. I guess I don't have a design that I need to open, do I? We don't have any design in here. I do need to see whether or not I've got the Pico, sorry, the Raspberry Pi Pico. There we go. I gotta see whether or not I have that in here. So in my assets, no. Admin, 3D part, no library, 3D models with 3D pads. Let's try part, no library. Let's just see, because I'm gonna have to get one from GrabCAD. Yeah, it looks like I don't have. That's the Teensy 3.1, which we're not using. Rogers is not only expensive, but things like laser drilled micro vias and some other high-end manufacturing techniques cannot be used or have low yield rate. You only use it if you cannot do without it. I would assume, yeah, you would just want to use something that's cheap. But if you need it, I guess it's a silver bullet. Although at a certain point, when you're engineering stuff for like satellites, I don't know how much you get bugged by the bean counters. Like how much are they kind of leaning on you and going, I don't know if you want to use that part. And you're like, this thing's going to fucking space. Do you want to replace this in space? Because I'll let you replace that in space. And they go, okay, you could spend the money. 3D parts with pads. I don't think the module's in here. So we'll have to find one. I don't want to just do the RP2040 chip. I don't know how well that would go. There's a lot of support stuff. There's a lot of support stuff that goes with the RP2040, and it's just easier to buy one for $5. Let me get one out. Let me get one out. Ew, that's a gross thing to say to somebody. Can we do this? Can you just update the software and use cheaper stuff? I have a permanent vacation to go on as an executive. The executives are really breathing down my neck. They want to buy another yacht. And they don't have enough of our money from exploiting you. The satellites will listen a lot to what some company rep says and force you to do what marketing convince them to. I don't know how much of that there is. I don't know. That seems like a lot. There are some very smart people in industry. I would assume that they're a little bit more level-headed. That's more like a Dilbert comic than industry. And all this support crap, I don't know what I would be doing with. It's not just as easy as throwing down an RP2040. This is a 2020 Pico Pi. It's got the terrible USB socket, which we will replace. But I don't think our board is going to have accommodation for that. I guess we could just use the test points to get wires out of this. So maybe we'll need a cut around these test points so that I can get USB from the USB-C socket into this device. Certainly not going to leave it up to a vertical pad. DIO, ground, SW clock. I don't get why they didn't take the USB slots and the D plus and D minus and put it out to some pads. Because you've got these massive traces running down the thing for USB input. They go right to 2 pins. It would be a very easy thing for them to just give us 2 pins. Oh, well. So I keep a bribing stock for marketing. You keep a magazine from the 70s so that they open up the magazine and all the space technology is like old as shit. We're doing better stuff than this. Wow. Someone really wanted to get that 900 ohms on the USB lines, but they're USB like micro. They're shit. These plugs are shit. Does the modern RP2040 probably has USB-C, doesn't it? What RP or no Pico Pi? No, they're still. That's so dumb. Why did they do that? They didn't want to spend the money on the more expensive socket, is I think what was going on. Because they're not heralding it as being super duper ultra USB speeds. Although I guess they probably could do pretty high USB speeds because those traces are like straight on. They were like the first thing that went down on the board. It's like, what do I do first? Let me do the USB inputs first. And you just run them straight up the aisle. It's like the goddamn Philadelphia City Hall. And then here's the art museum with the steps. And it's just a straight shot. Yeah, I would think there would be USB-C ones because it's turbo annoying to have to deal with these things. Because look at this. Even on this one, you can see the example. And this is my industry experience. When you get these things from even people you trust, right? Even people you've trusted your whole life, and they just violate that trust. They just fuck your trust, right? Just straight and just violate it, and they just yeah, they never apply heat long enough on these anchor pins. And these anchor pins, do they have vias? Okay, they go through the board. So at the very least, the anchor pads go through the board. That's going to strengthen this thing massively. On some, they don't have metal pins that go down through the board, and the pads are just straight up on the surface with no vias. That's extraordinarily weak. That's as strong as like a resistor on the board. And if I put enough force into the side of this resistor, I could pop this off of the board because it's just simply the bonding strength of the FR4 to the copper holding on your entire USB socket. This here, right here, is the interface where the 10,000-pound gorilla is going to fart on your circuit. And so you want to make sure that these things are strong. The proper plugs give you every provision to withstand the just absolute monstrous amounts of force that a foreign plug that gets leaned on by your boss can put into a PCB. That's why these things break all the time. They're USB-C knockoffs. I mean, I've got RP2040 from Seed Studio that has USB-C. It just doesn't have enough pins broken out for me to really utilize it in the keyboard. This is the Amogus circuit because it's got all of these little soldery edge pads. These little Amogus. There's a pad under the ground jacket where the ground jacket is soldered to the board. Take it off, I dare you. I don't think I'm going to be removing the socket because I got these two test points right here. But I mean, I think the best way would probably, hot air would probably be the best way. That or get Chip Quick in here. And then you could jump over to the top and put a big wide soldering iron on top of this. And then the Chip Quick would remain molten as long as you're not cooling it actively. And then this whole thing would pop off. I had to deal a lot with these little guys on tracking devices. And so these circuit boards would come in and they wouldn't have applied solder enough. And since you're the first person to plug something into them, because we had special software that was like speaking to certain cell phone company chips, and it was sort of like only an industry tool. Oh, look at how easily that scratches. Anyway, you were the first person to plug this in. And so this had no relief on it at all. So you'd plug it in, you'd be putting a lot of force into it, not a lot of time on the solder here, crack, boom, explode, this socket comes off with everything else. There's plastic in the connector, so hot air would be tricky. Well, I mean, if you're removing this thing, you're basically writing it off. You're saying this thing is done. So if I applied hot air long enough, although I'd want to be able to get to the other side of the board, so maybe throw this on a solder skillet. That would be the way to go. Just throw this onto the skillet. Everybody becomes molten. Pluck this thing off really carefully, and then allow it to cool. You'd be reflowing your entire board, which would be a little irresponsible. They go in the oven. 275C is fine. I mean, you know, Chip Quick would be the way that I would default do it. I've removed these sockets before. They are a pain in the ass, but we don't have to remove this one. It can stay. This can stay. A bunch of RP2040 knockoffs with USB-C, and they're great. Fewer GPIO pins. Yeah, the ones I have are legit, but they're Seed Studio. The Zhao. Shao? Shu? I don't know how to say it. These little guys, these are RP2040s. They don't have RF, I don't think. But they're really good for, like, if you need something to crunch numbers. They're really good at crunching numbers really fast. And they're cheap. You know, the Teensy 4.0 is like $30, which isn't terrible for a microcontroller that can do 600 megahertz, but I haven't found a lot of projects that need that much speed. So getting something for a $5 that can rival it almost is pretty incredible. I think it's QFN. But there's a couple packages. There's a couple different packages for the RP2040. Raspberry Pi did a good thing making this chip. I think personally, they did a good thing. They made a powerful microcontroller with cell phone technology that we can then take and run with. And it is QFN. QFN makes it easier for people like us. People like us. Quad, flat, no lead. Story of my life. And we're using this in our design because I don't want to have to accommodate all this crap. All this crap. The clock, capacitors, little tiny resistors, some memory, and a voltage regulator. I don't want to have to deal with that crap. So I'm just going to leave it up to this board, which cost me a $5. Is it true that you can transplant only the chip and that's where all the logic lives? Everything else is just I/O. I don't know. I actually don't know that about the RP2040. I know that there's some EEPROMage going on over here. So I would assume that some settings are being transplanted to the EEPROM. You could probably, you know, simple enough move that over. It is very direct with the I/O, which is nice of our Raspberry Pi to allow. You don't need support equipment for that. I'm not sure about the bootloader either. I don't know to what end. I have not explored the Pico Pi and the RP2040 as deeply as I would like to. I don't know about recovery and repair. I know all about that with the Arduino, but not with the RP2040. I just don't know. Quiet, quiet. What happened? Where'd my music go? Is there like an error in the DJ set? Hold on a minute. Or just get quiet? It just got quiet. My music got quiet. It's DJ every day. No, I got it. Yeah, it's still gone. I know. It just got quiet. Buy a RP2040. Hello, RP2040. A microcontroller chip designed by Raspberry Pi. High performance, low cost, small package. Flexible I/O connects the 2040 to the physical world by allowing it to speak to almost any external device. High performance breezes through integer workloads, low cost, blah, 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 blah. Oh my God, there's so much stuff. ADC and temperature sensor. SRAM. For power users, for hobbyists, micro machine learning. Read all about it. $23.50 is a new one. Secure. Oh God. I guess people wanted it to be securable. SOT23 is a triangle. No, no, it's a series of squares. So I guess that's just showing off. I mean, there's a data sheet, but it's like, what do I need to do in order to use this? Floor log 2 non-volatile. Floor log 2 RAM. Type of core, number of cores, Raspberry Pi. Debut microcontroller from Raspberry Pi. It brings a signature. Oh, I didn't take a famotidine. That's why that burp was so spicy. You're a series of squares. My life is a series of squares. You're all squares. All of you. I need a heartburn pill because I had a, what's it called? Damn it, I forget what the name of the sandwich is. Never mind. I'll just not say it. I'm gonna get a bottle of seltzer. Those are just outside the shop. I think my microphone will reach. I think it'll reach. We'll see. Corned beef special. There we go. Why is my brain the way it is? I've got holiday fatigue. There's a bottle of seltzer. Probably wouldn't be a good idea to hit caffeine. Yeah, why'd they decide not to use triangles in the end? Actually, Fusion has a bunch of features for using quad whatever 4-point design triangles in their things that have Bezier curves associated with them too. So you can do all kinds of cool stuff with like car bodies where they have a sensible grid of quaternated polygons or whatever. Mm-hmm. Really? People have done that, I guess. So that's so specific. You can put that all in an RP2040, which is this. That is a very small, full Apple computer. I've got one of those green and black monitors that a friend of mine dropped off, and apparently you can just hook like a Raspberry Pi up to it with HDMI. I think a converter, I'm not sure. I gotta figure that out because I think that would be a wonderful thing to put chat on. If I could get my social stream blade to be on that green screen and just tuck that somewhere in the background, I think that would be really amazing. But as of right now, we just simply do not have room. There's zero room for anything in this shop. I need to do like a round of cleanup, or maybe I need to have a fire or something in order to really, truly clean up. It is a CRT monitor. It's an old CRT from like an IBM. I've got the rest of the IBM too. It's just I don't do that much with old computers, so I don't really know what to do with it. All you need is a VGA adapter connected to the right pins. That's Evanson. It's the one that I have is not Mac. It's an IBM screen, but it's one of those green and black ones. And I've seen the full Raspberry Pi OS up on that screen with a fair amount of detail for being 1-bit color. Chat over serial with an old terminal. Flatulent Gonad knows a lot about that, actually. He was using AI because his coding skills are not amazing. You know, not everybody's an amazing coder. Can't just throw up code out of nowhere. But what Flatulent Gonad did is he asked the shit out of ChatGPT, and it was able to spit out code that was reasonable enough for him to get old vacuum fluorescent, VFDs, vacuum fluorescent displays, character displays to display chat. And so it'd have the username and the chat message, and it was doing that serially. So he'd be the person to ask about that kind of stuff. VGA Apple would be fun. I have so many old VGA monitors that I can't use anymore. That's sort of my justification, is that it looks cool. The problem is I don't have space for it, but it would be cool to have a scene that's like this old computer that's got, you know, all the chat messages going up on it. And actually, Uo's Lab did that. He had like an old programming book that he was following, and I think he was able to get chat up on that screen. But I want to cheat. I just want to plug a Raspberry Pi into it. I don't want to have to use an old dumpy computer. Because that way I could have like 1-bit emotes show up too, and I could see what you guys are actually typing. Because I need to keep my eye on you guys. You guys, you know, unmoderated chat. Ooh. I had some of those monochrome green and amber monitors when I was a kid. Hand-me-downs. Even back then, you were better off using the color modes because you got grayscale and better quality than the monochrome modes. Yeah. I don't know to what end. This thing has sat in the garage for 75 years. Whoever bought it is my friend's rich wife, his family, who probably bought it like, computers, the new thing. Let's spend $10,000 on a computer. I watched that whole video about the largest CRT in the world and what that guy went through to source it, and I shared it with one of my mainline friends, the rich peoples of, when we were all kids, some pretty significantly rich people in the circles that I would hang out with. One of them said, yeah, it was not a good video though. The trolling at the end was just the perfect thing ever. But one of them was like, I think my dad had that. He was into AV. And I'm like, can an anesthesiologist afford a $40,000 monitor, like CRT screen? I don't know. I was like, dude, go through some stuff and find the operator's manual, and then I'll believe you, because this TV is so incredibly rare that I doubt that you were a small little thing back then, and every TV looked like that giant TV. Seeing that big monitor next to like a normal big CRT screen was incredible. It's like if you play 4-player Mario Kart, which has this weird gang symbol that you have to do 4-player Mario Kart. This is the symbol for 4-player, also GoldenEye. This is also the symbol for GoldenEye. 4-player split screen. Each person had their own 27-inch equivalent monitor to view on that giant display. Craziness. Absolute madness. Players reading all the younger audience panic when he was slapping the crap out of the monitor to get it to work. Yeah. I would definitely, if I lived near that guy, absolutely lend him a hand identifying all of the individual electronics and replacing it with new ones, in order to get that chromatic aberration and all the other stuff to go away, because those manuals are insane. They're so amazing. But that guy, so many like lucky coincidences on his hey, what's up, blonde dog? So many lucky coincidences. He just like asks about this TV based on an image, and finds somebody who's dedicated in the same like city in Japan, and it happens to be the last week before they junk it. And the owner is just like at ends. He's like, this is such a special thing. How can I, this is like a flagship technology. It's so amazing. I just want to give it a good home. And then this guy suddenly just says, hey, I heard you had the biggest TV in the world, you know, CRT in the world. And then just to be able to coordinate all that stuff like a week before the TV was destroyed is just insane. Absolutely insane. And then somebody who's just talking, we've got a lot of people, even in this community, and I don't name names because it's kind of mean to do, and you never know what somebody's circumstance is, right? But people talk a big game, especially to me. They say they have robots and laser beams and all kinds of cool stuff, and they live the life of a Bond villain. I don't question it, right? I go along with the flow. That's really cool. I would love to see that. You know, somebody like that in the CRT community was talking about having all of the manuals and the service manuals. And this guy took him on his word and said, I would love to see that because I'm actually sourcing one. And the guy actually pulled through and had it. Insane. Just these kinds of like coincidences that I would never in a million years believe could happen. This person was able to leverage and got this huge CRT. I love that video. It's from December, and I forget what the channel is, but it was just an amazing like community coming together. It's very cool. Yeah, the video is doing its rounds. I think I retweeted it, re-skeeted it. We got to come up with a better term. They call them skeets on Blue Sky, because the creator of Blue Sky hates that term, and I'm with him. I hate it. It is Sony. I'm unsure about the size, but it was, yeah. Why do they call it that? Why? You can't say that in polite conversation. Come on. Yeah, hey mom, I found this new skeet. You want to see? Oh God, it's horrible. Used to deliver TVs back in the day where 36-inch Sony was a monster TV and a weight ton. Yeah, this thing had specific instructions. I had to move a friend's Sony Trinitron at one point, which is like, you know, the more affordable giant CRT, and I couldn't do it. I was too weak at the time. Probably too weak now. I did bulk up a little bit over a period of time, so I'm not necessarily that weak anymore, but at the time, it was a beast, and I couldn't even lift it. It was like something along 400 pounds flat CRT. It was that deep. It was like 2.5 feet, maybe more from front to back. Just didn't fit in the normal spot. Yeah, and you had to have the stand that came with the TV. This one, the Japanese one, the Sony one, actually had you make sure that the floor was able to support the weight of the TV. Insane. Insane. I found that very fascinating from somebody who dropped CRT monitors the very second I was able to get an LCD at an affordable price. As soon as I was able to get an LCD at an affordable price, that's it. I didn't even care that in the old days, you couldn't see an LCD from a little bit of an angle, and that they weren't widescreen, and that they didn't look right, and that all the colors were wrong, and that the delay was like a half an hour until the display updated. I didn't care. I got that thing immediately because going up, bringing the giant flat screen monitor up a flight of stairs was a thing of the past. I said, absolutely fucking not. No way. I will go through any hardship other than carrying 40 pounds, 60 pounds of glass and metal up a flight of stairs. Yeah, worst part of moving to a new place is transporting the massive CRTs. We did a lot of LAN parties back in college, and I was carrying a lot of monitors in and out. And then you have your tower that's made out of just metal scrap, and so that also weighs a shit ton. Is a nightmare. Now I've got this little thing. It's a little handheld that I just take with me, and I throw a keyboard and mouse on it, and that's it. I can play most games aside from like headliner AAA, but we don't do that with LAN parties. We play dumb little games that are fun. Yeah, those TVs were workhorses back then. Those, you know, hey, they were not making the technology to become obsolete. We talking gaming a little bit. We're always talking gaming. Didn't turn off until 10 o'clock at night for 15 years. Yeah, and everything kind of flexes a little bit. I have Fallout 76, and I spent about 5 minutes playing it. My friends decided that they would return it because they didn't think that it was good. We played for like an hour and a half. We had a timer going, and they decided that they didn't really like it. A lot of the stuff that like single player Fallout kind of rolls you into is not really there in a sort of MMO, because you have like, I'm going to sneak up to this compound, I'm going to loot it, I'm going to figure out what technology is there, I'm going to take it over or destroy it, and then I'm going to sneak my way out of there without anybody knowing that I'm around. You do that, and then somebody else is just running around the environment like blowing stuff up in the meantime. It's just like, I don't know. I like shooting bugs. Yeah, I assume that there's a very fun time to be had there. It's different. It's not the Fallout that I like. You guys have heard me talk about this before. I cut my teeth on Fallout 2, which is a single player game. It's an isometric single player game, and I loved playing that and sort of exploiting that and doing weird builds, or just figuring out like mechanics of it, or how to get around something and do something I'm not supposed to do. Like, I love that facet of it, and I like sitting there and just kind of, me versus the game a little bit. I'm not sure if the MMO is going to scratch that itch. I didn't return Fallout 76 because we played it for, more than an hour and 45 minutes. We played it, and I had a good time. I think I spent a bunch of money on it. I don't think it was on sale at the time. I probably could have gotten it for $10. It might have been on sale, actually. I don't remember. But I feel like I got my fun out of it. I don't know if I'm going to return to it. I wish I did. I kind of wish I had time. But crackle and make popping noises. That's just a static electricity. I miss the sturdiness of the old PC cases made out of actual steel with reinforced bars. They kind of they're still kind of like, you can still buy those. You could actually put a heavy CRT, books, and other equipment on top without them being under the weight. If you buy a fancy glass house, you cannot put books on your house. That's how glass houses work. But if you buy a steel house, you can put books on your house. They still exist. It's just everybody went to fancy glass computers because they look neat and you get to show off your technology. I got made fun of for cutting a hole in the side of a PCB, or sorry, a hole in the window of a PC and trying to put plexiglass on it. What do you want? You want to put a sheet of plexiglass? What? So people can look into your computer? And I'm like, yeah. They didn't understand. I was making a lot of noise in woodshop by cutting it. So I guess that's why they didn't appreciate it. But really, the robust ones tend to cost 2 to 3 times more. Sheet glass that cheap? I guess just volume and manufacturing. What the real power play to do is to get like an old e-machine case and put your modern computer into that, because the standardization of ATX and all the componentry, it still fits into your ancient 90s e-machine case. And then you throw that thing up on a table at a LAN party and it's running like full graphics and people are like, wait a minute. Actually, they're not like that anymore because that's so common that everybody knows about sleeper PCs. Everybody knows about sleeper PCs. Nobody would be shocked about that. You could take a microwave and put a PC in that. That's a nice sturdy case. The PC case still like that, from what I've seen, are some pre-builts from Epson. The only thing available in Japan, and rack mount ones. Every modern aluminum, cheap plastic, and glass. What? Hold on a minute. Tiger Direct. What was that PC store that I don't ever use? Products. Computer, go away. Products, computers, business solutions, desktop, laptops and tablets, computers, electronics, PC builders, there we go. Racing sim build, no. Completed builds, no. My build dash, this is some weird thing. PC parts, there we go. Computer memory, no. Cases, desktop cases. Glass, 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 ass, grass. Fractal, mesh. Still has a glass side, but it looks a little bit more robust than your typical $150. Jeez. I remember when cases were like 60, 30. I actually do like this design, to be honest. I like this design. I like the little I like a mix of materials in my computer. This looks decent. You could probably put a couple books on top of this thing before it shatters. The PC cases like that, pre-built Epson. Take a look at one of these classics. I actually have one. Yeah, it's, you know, the full tower cases. I remember a friend of mine had one. He did nothing but put fans in it. It was he would feel around inside of his case and find an area where his hand wasn't slightly cold. And he, oh, that's dead air. And so he'd literally just throw a PC fan into that area. He had fans that were suspended on cables. They were like, kill me. Like, it was amazing. I gave him a Peltier cooler that I had, and he wired that up in the case store. So he had a Peltier cooler desperately trying to leach away heat from his computer. And he absolutely 100% min-maxed that thing and then blew up my graphics card that I gave him. What in the Sam Hill? 6U server rack. Steel frame. Weird. Yeah, so I mean, even I'm just looking at like the base layer Micro Center stuff, and I'm not seeing a lot of stuff that's sort of robust, if you will not mind me using that word. This one looks pretty tight. It's tough to get a whole PC into something like this, but it can be done. In fact, this is probably the direction that I would go in if I weren't too far up my own ass building custom cases. Those cables, people say slow down the graphics card. It really doesn't. It really doesn't. You're not going to really notice a difference. Although I bought a $100 and something 3M one that was very specifically shielded for this sort of thing. But Linus put like 7 of those things in a row, and it didn't really affect graphics performance. On a very minor way, it would, but here's the real power play. If you want to get into robust PCs, you just buy this. You just buy a server PC case and throw it in there. That's what I did with the with this computer, the computer that we're using right now, the stream computer. I just threw it into the case, and I opened up the front in order to do water cooling, and it wasn't $300. It was a way cheaper case. It's actually a very cheap case. It flexes in all kinds of weird ways. Cooler Master, Micro ATX, North Tower. Absolutely no frills, although it is a little bit miniature. There you go. There's your strong case. We get down to the $60 cases and you start getting, I mean, the sheet metal's thin, sure, but if you're talking about a computer that you can stack stuff on, there you go. Not quite as robust as the old sheet metal computers that we used to use, but close. So I don't think it's totally unavailable. I think there's still a category of PC case in sort of the dumpy dregs. This one's cool. It looks like an air filter. And it probably acts as one too. Yeah, see, there are the fans. Ugh. I actually don't like the look of that one. It looks like an air filter. What is that thing? Ugh. Yeah. I don't know. I'd be hard pressed to find something that I'd like. Something that I would be willing to carry from LAN party to LAN party, you know? HEPA compliant PC case. It gets all the dander out of the air. Computers stacked on computers. I guess that's what they're made for, you know? Here we go. We can harken back to the day when everybody had Oh, these are this for your media PC. This is an old case, actually. This is old. This thing's been around for a while. A friend of mine had one. Hell, I might have bought one. I have a case with a handle on it for a while in the 90s. There was that Lian Li case that was built like it was a piece of tactical gear. That one's a good one. That's kind of cool. But again, yeah, the whole purpose of my looking this stuff up is that like computers are being made cheaper and cheaper, and the sheet metal's getting thinner. And if you put a stack of textbooks on top of this thing, it's going to break the tempered glass because it'll flex the case. Because while they are built the same way, with all of the overlapping sheet metal structures that are riveted together and all that stuff, the material itself is getting thinner because shipping is expensive, and you got to pinch pennies anywhere you can. Apparently, this is a $40 case. I mean, what you would do is you would get this thing and you would put it flat, and then you put your monitor on top of it, and then the tempered glass shatters and your monitor hits you in the face. And yeah, that isn't even a case. Yeah, I mean, if I were to build a computer and I wasn't so inclined to do my own, and I wasn't so inclined to sort of do my own style case, I would definitely be looking at these shuttle PCs because there's a lot of really cool design in there. Second to the shuttle PC, I would definitely go with the wood slats. Father's 8020 rail PC. No, I have a MakerBeam PC. That's literally what I built mine out of. You were there. You were all there. Every one of you was there. That's what that purple monstrosity is right there. Oh, my arm. That right there. That's MakerBeam, and it's my PC. There's all my PC stuff's in it. We nickel-plated the things. Nickel-plated. How cool is that? Oh, we're at an hour. I should probably actually start streaming if I want to get anything done. But yeah, this one right here is my second place for what we were looking at today. I just like the wood. I like wood. It's a preference. You know what you want, and that's what I want. But again, I'm not making computers like this. I'm building it up from scratch. And our computer project is actually going to take a turn because I'm going to try to put it on a rack shelf so that it'll slide out on the new desk build. The new desk build is going to have 19-inch rack, I think, on both sides. It's going to be the size of this slab right here, this piece of wood. And so if I have 19-inch on both sides, then I can have all of my audio gear on one of these pull-out shelves, and then I can have the computer on another one. Although I may want to look up, hold on, let's just look. Oh, that's the wrong PC. Whoa. Okay. Where would that be? I guess I could just do Amazon, which is going to be the cheapest thing ever. Something a little longer. Maybe a little bit more per $123. Are you kidding me? Ugh. Cheap. Everything here is so cheap. I could probably just get drawer slides and build my own out of MakerBeam or 2020 rail. That would actually be much cheaper, wouldn't it? Instead of $90. This doesn't even have slides. If I just get slides and then do it myself. Oh, see, these slide out insofar as, oh no, that actually slides out. See, this would give me more room behind in order to build it. I have a Game Boy Color shell that was dipped to give it a wood grain look. I did that with the Switch that I have. We bought wood grain plastic pieces to replace the original. We did that on a stream. It was fun. I like having the wood grain on the Switch. It's a little juxtaposed. Yeah, so like something like this would probably be pretty good to build a PC on, especially because it gives me more of that horizontal room. And then the rack slide that Julian gave me is better for the audio gear. so I can slide out the headphone thing and plug into the headphones and not have all that crap on my desk. I can have my desk be flat. I can move my USB hub to the back of it, so USB would plug in vertically at the very back of the desk. Matched brass buttons and wood body. I wouldn't like that, because then it would be plated brass plastic and it would be way too bright. I would want it to be like scuffed. Get an old Supermicro 4U chassis off of eBay with rails and put your PC in that. It works great. I still want my PC to be like a weird series of tubes. All right, well, anyway, that's $123. I'm not going to be buying that. All right. Hi. Let's get the music out of here. Let's get the music out of here. Hi, what's going on, everybody? Welcome to the holidays. It's Friday. I don't want to do too much thinking today. I guess technically this is a hashtag AutoCAD ad, because what we're going to do is start exploring a new project that's an old project. Some of you were around for when I redid all of my computer stuff. I have a code 10. Where did that come from? There's a smudge on my finger. I have a code 10keyless keyboard, right? And the code 10keyless, hold on one sec. Okay, so I have a code 10keyless keyboard, and I feel like I have Stockholm syndrome because I love these things. I like the form factor of the keyboard. I like the Cherry MX Clear, the amount of throw that it has. Just sort of, it's a snappy little button. It's done me good. It's done me so good that I have two of these things sitting on my desk right now, and one of them is irrevocably broken. This one right here suffered from what the old one suffered from, which was spill. Code puts the main processor right here, and somehow this space right here, being on the end and being close to the bottom of the keyboard, means that if your Coke has a unfortunate little accident, I mean the liquid kind, it ends up getting in and under, and it will get to the clock of the microcontroller very easily, and it'll kill the clock. I'm not sure if it's just the clock that goes bad. It might be the microcontroller itself too, but it'll render your keyboard completely useless in a very quick instant. The thing is, the crystal clock that powers most of these microcontrollers have an air port, not like runways and stuff. They have a port for air underneath them. So if you conformal coat something, you want to put a mask over your clocks, because your clocks won't necessarily work on elevation changes and stuff like that. So, yeah, don't seal your clocks. So anyway, the point is, the 10keyless puts all that stuff under the circuit board, where it's like probably the best place they could put it. It unfortunately is exposed to the elements, my elements, of spilling soda and stuff that way. And so I had the damnedest time. The microcontroller just died on both of these keyboards. Turns out there's something called Quick Mechanical Keyboard, and QMK is a system by which you can use a variety of microcontrollers in order to take over your keyboard and get everything working again. So QMK with the RP2040, which is this microcontroller that I'm sitting here, this is $5. The only tough part about that is hooking it up. The thing about the code 10keyless keyboard is it scans in a particular way. It actually scans from the middle out, because your hands on home row, they say that they get better performance with that. I think it's a bunch of marketing gobbledygook, but it is not totally without merit, because they do actually have that system. We discovered that because we've already taken over my other keyboard. And so we've got a working document here where I know what all the connections are to this thing and how I ended up wiring it in order to, in order to work with the original processor of the keyboard, the SN8F22E88 BUF. So we have this working document about exactly how I hooked this entire thing up and got it working with the RP24. We used Max 308 muxes because I happen to have them. The Max 308 mux, just barely fast enough to do a hello from Romania. Oh, good to see you. I was wondering when you'd get here. So the Max 308, old chip, it is really good at analog switching. It does a full disconnect and then a reconnect. It's good for like instrumentation, right? This is an instrumentation. This is a digital keyboard. So we don't necessarily need to put in a Max 308. especially if I'm designing a PCB for these, the Max 308 might be a bad choice. May try to find like a digital mux that's a lot faster. Or I just roll with what I know works and we just do this. What we're doing is we're going to try to translate this design into a flexible PCB, a flexi-pcb. This is basically this stuff. This is Kapton tape, Kapton. Kapton is a trademark. There's another name for this stuff. It's got a specific name. It's one of y'all is gonna know it. I have chat turned off except for up there so that I can do my intro properly. But it's basically if you etch away copper and you leave this behind and you put another layer of that on top, you now have a flexible PCB, right? It'll still shear the copper if it flexes too much, but it makes for just like a unique shaped PCB that's very thin, and you can solder it onto other PCBs. You can use it as a way to get polyamide. There you go. Thank you, Incredible Mike. It makes it so that you've got kind of like a flexible light PCB that can withstand a lot of stuff. So the idea is that we can use QMK as I already have it configured for the RP2040 for the code tenkeyless. Because again, I like this keyboard. I spent a lot of money on it. I have a friend who has one too. Maybe if his keyboard dies, I could take over. Well, then again, the PCB that we're going to make is very specialized towards the tenkeyless, just because of the amount of rows and columns and stuff that it has. But, you know, I got this working on this keyboard, and it works extraordinarily well. The screen over here broke. I need to 3D print a better screen holder. But yeah, so I've had a lot of really good luck with this. I mean, it works just beautifully. There's a company making faithful reproductions of the IBM Model F. I've got one sitting over on the shelf. Why would I do that when I could just throw a USB into that thing and take it over with QMK? But those are too loud. They sell for $400. Buckling springs are a specialty thing, man. But okay, anyway, so the point is I can add my own muxes. We can search for a more modern mux to go on it. The real challenge is that I want to keep this within 100 by 100 millimeters. And we'll have to see what exactly I can do within 100 by 100 millimeters in order to take over the keyboard. I had to make some considerations when I did the soldering on this because the smallness of the whole thing. But if we're reaching all the same spots as the processor reaches, then I think what we can do is on our flexi-pcb, we can have just a little square cutout and then all these edge pins surrounding it. And then I can solder bridge from the pads that are on the keyboard to the pads that are on the flexi-pcb. Bob's your uncle, right? And then that'll make doing that really nice and easy. And then double-sided tape the RP20. The RP2040, of course, will have to have just pads on the thing because it's got provisions for that sort of soldering. That's what these little Amoga pins are. They're plated on the edge so that you can solder them down. So we'll have pads flat on the orange PCB. The only thing that I'm annoyed with Raspberry Pi for doing is not really giving us any provisions for these. I would have loved it if these test pads could have been edge pads right here, and then you could desolder this plug and have, you know, a proper wire connection. So I don't know if I need to have like a cutout here or if I can do something else a little bit different. What we did in the original one was I scratched the tops of these two massive traces, and that's how I got USB into it. The code tenkeyless has an integrated USB-C plug that I plan on using. So let's take a look. Let's take a look inside of this thing, and we'll take a look at the work that I did, and we'll see what, well, difference between the two keyboards. Keyboard's really easy to take apart. It's really easy to take apart. And actually, one of my more grandiose plans of this thing is in the future, I would love it if I could get a router, get a CNC router, and get some nice wood, and actually make a wooden case that just magnets together to hold this thing. So that in the event that I spill something in it, I can rip it apart very quickly. But yeah, I love I love the form factor of these keyboards. I like the weight of them. They use a big steel piece to hold all the keys in. The only reason I want magnet assembly is for when I spill something on the keyboard and I have to get it apart within like a millisecond. And also just the wear and tear of this thing snapping together is really getting on my nerves. It's the edges all chewed up. I mean, not just two. You could do like all around the perimeter and have them snap together, and it would really hold it. Oh my god, it's disgusting in here. It's like an ant colony. All right, so here are my mods. This is what I did to the keyboard. What have you done to my beautiful keyboard? We're trying to replicate this, but with a flexi-pcb. It's going to take up a lot less room than this thing does. Yeah, so here's where the original microcontroller sat. How dare you stand where he stood? There are a couple little peripheral things that I've hooked into, and those would have to be on pads. This is going to take us a while to kind of put together, but I mean, I was very careful about how I ran my wires and stuff like that, and I held them down with a little bit of UV glue, and we soldered in directly to these pins. I have to be really careful with this because I definitely want this thing to survive because it's my only working keyboard right now, except for the really tiny one that I have on this streaming computer. But yeah, we basically took it over and we left it to a couple of muxes in order to activate rows and columns of this thing. The unfortunate bit is that there were like just too many for this thing. I could probably find a mux that would be like an all-in-one solution for the columns and rows, but I actually have it scanning 2 rows at once, and it works just fine. It basically scans two columns, I think, outward, and then it goes row by row. So it's actually a whole thing where it's doing this crazy scheme to scan it. And then here's the RP2040 all connected up, and I have USB that's been taken over, and I have that running over to, I believe, this is like a lighting controller. And then I somehow have it hooked up to the original plug. So the question is, can I do something with a flexible PCB that's going to drop in on all of these pins and take over the job of this keyboard? And I guess maybe I'll have to have a couple of peripheral connections here. It's a lot of cables. Well, that's why I want to make a PCB. I want to make a 2-layer PCB for it. I think that would be a really neat thing to do. But I know nothing about copper flexi PCBs, so this is going to be a kind of a weird project. Oh, and then of course I'll have to also have pads that lead to the screen because the screen is serial. I've got 2 going here and 2 going here, and then the screen's just on the other side of this position right here. Preferably as well within 100 by 100 millimeters, right? And the RP2040 is going to have to be along with that 100 by 100. So what are the restrictions going to be? You guys are talking the Model M clones here. All right, 100 millimeter by 100 millimeter. What kind of restriction is that? That's pretty big. That's actually pretty big. That's pretty huge considering 100 by 100 is a big, that's basically the entire theater of operation for the old. Wow, that's holy crap. So if I literally made the orange flexi PCB in the exact image of this circuit, that would be perfectly acceptable. Although to be honest, I would probably rather have it down a little bit, but I'm not sure if that'll work out mechanically. So basically I can just do this. I can have it do that entire thing. I don't think I can have it come out to this though. That'll have to be my own little custom jobby. That's the button that I can reprogram the thing with. The blue and red bodge wires look amazing. I put a lot of work into this. This is what happens when I actually get my medication. Yeah, I didn't want it to be a bird's nest. Oh, the soldering of that one is a little bit to be desired. It's fine though. This keyboard has worked perfectly fine for quite some time. But this is the kind of like bodge wire work that you can do if you really put your mind into it. I kept these around because these are switching high current stuff. Actually, I think it's these. These do 3 banks of LEDs. These are not good connections. I do not like these. I don't like those at all. They're quite bad. They disturb me quite a bit, but I try not to think about them. Yeah, it's a lot of little connections. I don't know about whether or not I would want to connect directly to these if I solder them down. Where are these connected? Those are all the black wires there. Yeah, they go to this area. Oh boy, and then there's a little logic that I put on top of this thing. I think I documented everything, so I think I've got good documentation for it. There's a lot of bodging going on. That does not look soldered. We would be able to translate over to a flat PCB, and it would look a lot less embarrassing. Yeah. Well, point-to-point wiring can be a lot cleaner. Let's be honest. If I had my hot pincers, I could probably do a really good job hot pinching these to be open. It would look more like this bank right here that kind of wraps around. You know, it's always good to document this level of pure horror. Oh, shut the fuck. You shut your mouth. It's not pure horror. This is fine. It's just there's a couple areas that are a little bit rough. Just a couple of areas that are a little bit rough. Basically, we take all of the rows and columns out to the max 308s, and then the max 308s coordinate that with the digital pins of the microcontroller. So the microcontroller tells it, you know, flip on this one, flip on this one, flip on this one, and depending on what it sees back on its, I think 2 banks, it will then count as a key being pressed. You have a lot more patience than I do. I didn't have my keyboard, and I really wanted to fix my keyboard. You guys go on about me never finishing a project and how I'm always waffling around at these same projects day in, day out, and never getting any fucking shit done. Well, I'm here to rub this in your face. By the way, AutoCAD has sponsored this stream. Thank you for sponsoring this stream, AutoCAD. I really appreciate your software coming to me for free for using it. We're going to try to do an orange flexi-pcb with hashtag AutoCAD. Meanwhile, I'm sitting here calling you guys a bunch of fuckwits, trying to rub your face in my urine. No, trying to rub your face in my project, saying, hey, look, I do actually get stuff done. So we're going to try to put this to an orange flexi-pcb, and it will hopefully be a lot cleaner than this. There's also no reset button, is there? Where's that reset wire going? Oh, that comes all the way around, and then I had to reroute it, and it goes all the way to that, which is connecting it to this button. That's just that button over here. Brain's too smooth to understand what I'm looking at. So what you're looking at is an RP2040, which is a microcontroller, and it is connected to these 3 analog muxes. They don't need to be analog muxes, that's just what I had. And these 3 analog muxes, what their job is when the PC activates certain pins on those muxes, they will connect to certain banks. So what you have are 8 inputs and 1 output. And it's actually I/O, it's in or out. What we're doing is we're using that in order to charge a row or column with 3 volts. So if I send it the binary equivalent of an 8 on these pins, it will connect number 8. Number 8 will then be connected to 3.3 volts, so that anything on that row of the keyboard that's pressed down will be recognized as 3.3 volts coming back. In order to look at the different rows, I have another mux, so that if this thing activates 1 through 8, if it activates like 3 gets connected, and then we're looking at that specific row, and that specific row has, data coming back into the microcontroller, basically. So it's basically scanning row by column to figure out what buttons are being pressed. That's it. That's all it is. Muxes are just a way of connecting a bunch of stuff to one line and isolating it. Yeah, we're replacing the brain by giving it a switching scheme. I guess it didn't have that squelching scheme. It didn't have that switching scheme I mean, so the muxes do their job just because we have just under the amount of free pins on this microcontroller that we would need to go directly in. If we went directly in, we would just tell that pin to go high or low, and it would activate the row or column, and then we'd read back what we could. That's the way that this sort of originally worked, right? A squelching scream. But so anyway, we have analog inputs. We've got, yeah, these guys coming back in to very few inputs indeed, but it doesn't max out our peripherals, and that way we have enough left over so that we can do things like control the RGB, or whatever the hell this thing is doing. I don't even know. WTF. Great, I've got all these wonderful notes for myself. It's got some way of activating multiple banks of LEDs, and I took that over for the thing over here, but what are these though? Oh yeah, that's right. These are the I never got these to work. The num lock and caps lock circuit is a little bit weird. Yeah, the reason for the muxes is just simply that I didn't have enough pins. What the original did is this microcontroller would communicate with the lighting microcontroller, and the lighting microcontroller would take over for all those other funky things. And I think this one is actually able to program the other one, because you could reset it to like default mode and stuff like that. But QMK has all of this stuff. It has all of that stuff already worked out. So what we can do is hopefully make an orange PCB and have it be nice and flat down to this. So I come in here and I remove all the stuff like I did here, and then we paste down our PCB and then solder it all along the edge. Yeah, numlock and caps lock lights have RGB, and I didn't do much to take that over. I can control it. I don't really know how. So that's one thing that we could probably work out. But then we can also add a screen to it, so there's no ambiguity about stuff going on. So we can have this SDA and SCL go to a display, and that'll just be two pads on the PCB. I'm doing it this way because my other keyboard, my backup code tenkeyless, is dead. This one's also dead. So, and we did all of this work to figure out, and again, you guys can't say, his bother doesn't finish projects. I did all this work to map the keys, the rows and columns of these keys, and figure out who was where. It was an intense amount of work. So it goes row by column, and each of these rows and columns has certain keys on it, and you want to make sure that it doesn't get confused so that everything is correct in the thing. It is a nightmare. But the way that it works is that, and you can kind of see it, it has like, it fans out in the rows for your right and left hand. It's pretty crazy. Okay, so I need to figure out how we're going to get this design down onto AutoCAD. And I've got AutoCAD started up. We have our circuit. I guess what I need also is an RP2040 part. So we start in parts creation. And it looks like, you know, my initial assessment, how do you build a PCB, right? Where do you start with a PCB? Well, for me, it's mechanical stuff is really where it begins, right? Am I able, all this to avoid drinking over the keyboard? We love to see it. What are you talking about? It's to take over a nice mechanical keyboard. So yeah, when you start making a PCB, it's like, well, why do I need a PCB? I've bodged it and it works. I would like something that's a little bit more fixable if something goes wrong, something that I don't have to like be careful about when I'm working around it. And yeah, if anything goes wrong with this, I mean, I can even undo all of this and put the orange PCB on this if I really feel the need. The first couple things that you assess is, do I need to do this? And you know, it's getting to be about time. It's a Good Friday project, so we don't have to think too hard about this. And I think I'm well justified in spending $2 on the PCB. Although that's probably just temporary holiday pricing. By the time I actually get around to ordering this, it'll probably be expensive again. But the orange flexi PCBs have gone down so far in price. And an orange flexi PCB is really good at this kind of a hardware takeover project. I've always wanted to do something like that. No, they're only double-sided. Yeah, the polyamide circuit boards,
I don't think I've ever seen one that's 4 layers, and I think in the instance that I might have, it was very unflexible. It didn't have all the flexible properties of the typical polyamide. But they're down so far in price that it would be like $40 to get 100 by 100 PCB, 2-layer polyamide. That's amazing. And so we could, within our 100 millimeters, look at that. That's 100 millimeters. Holy crap. That's like the whole thing. That's the size of the keyboard. It's not, because the double-sided has gone down significantly in price. If I did a regular FR4 circuit board with 100 by 100 millimeters, it'd be $5. So it's proportionally gone down, and both of them have gone down in price. But if I do the flexi-PCB, it'll be very thin, and it will be able to flex down and get parallel with these, with the 4 banks of pins that are required for the microcontroller. And it looks like I'll be able to do both this and this. So I will actually be able to have all the right holes in all the right places. That's crazy. Let's get the other keyboard taken apart so that we can get better measurements of everything too. I guess first I'm going to get an RP2040 part in AutoCAD. So that's a GrabCAD thing. And I decided to put it up here. I could, well, we have a plug right here, but I mean, I could just move in on that a little bit. Man, this is crazy. This is crazy. We could even put it here, because it'll be 3 of those chips and this thing, and then a whole lot of routing, and that's pretty much it. This is using an existing hole that has a dip switch, and I use the pins of the dip switch to hold that up so that you can get to it externally. So all right, here's the one that I haven't taken over. Here's the one that I spilled shit on. Should probably use the case for this one on the better one, the one that actually works. I may do that actually. I may do that. I may use the better plastic case on the one that still works, because this is going to be our working model for a little bit. Actually, don't want to bend these. Let me get a better spudger. Spudger! Don't get caught in the spudge. All these are broken on this one, all the little tabs. Actually, I think it's better to do the front. I've only ordered flex cable connector for displays, never actually put more than a few ICs on them. Same. I've never really used flexi-PCBs. I have had many people ask me about them though. Hey, we need a flexi-PCB for an art project. And I'm like, run, just run. Don't do it. Don't use flexi, because they used to be really prohibitively expensive. And this new cheap PCB thing is routinely shocking me. Come on. Ugh, damn it. So what is this? Is a push-in tab? Oh, this one doesn't have any tabs left. Okay, so it's just a little hook tab. Most of these are broken. Yan Wen? Never heard of him. Don't even know the guy. What I'm trying to do is push down on it a little bit so that it disengages, but it's got its buddy around the corner is backing it up. So this is going to be fairly difficult to open up unless I use exceeding amounts of force to do so. So I'm going to have to get a better spudger. We have better spudgers. We'll see how damaged this one becomes before I give up and use something even more of a nuclear option than this thing. This is sent in by Twisted Sister, because he saw me trying to spudge with anything but a spudger. Anything but a spudger. Any spudger in a storm. We'd probably be better over here where things are a bit more flexible. This thing just gets its whole ass in the way. And we get more of the flex of the plastic out here. Although it doesn't have the room behind it to sort of flex into. Now, it's still fighting me a lot. Ocean Parks used to be the cheapest way to get PCBs. Now everybody's giving them away. Yeah, well, it's the machines have gotten cheaper, and the older machines go to certain operations and stuff from like big You know, these machines get bought and sold all the time, and sort of the new thing that they do, and this isn't very new, but what they do is they get a big panel and run it through the big panel machine. I see this thing is on the other side. You know, panelization's been a thing for quite a long time in manufacturing custom PCBs. It's just the machines have sort of trickled down the lane. You know, they've been inherited and all that stuff. And so these places are able to do it. And the proliferation of the electronics hobby has really taken off. And so people making stuff like keyboards, custom, is so much more accessible now. The volume of people looking to make custom PCBs is much higher. Get a little gap there. This thing won't go in. These are clay working tools. They're not really meant for this. That's a little snappy. We need to push this one down and then the other one out. The bottom piece needs to go out, but it's got a little lip on it because I hate this kind of design where it's great at holding together, but when you got to go into it, everything explodes. Did we take the screw out? We did not. Do not remove. Okay, don't remove. You got it. You got it. I won't remove. Fucking. You're a sticker, not a cop. You can't tell me what to do. Who do you think you are? And it says void when you remove it, but that's illegal. Not allowed to do that. They're not allowed to do that. Come on. Yeah, this is where the edge gets chewed. Because I have trouble with getting these. Oh, jeez. They're so violent. This one's probably broken. Yeah, they put a little plastic wall up behind it too, just to keep you from doing that. I mean, if you really know where these are, you could probably get in there and actually flex them out, but I just pull as flat as possible to try to keep the thing from snapping off. Coder watching have just ended the warranty. I spilled shit on this thing so long ago that it's just over. It's over. It's Jover. Is that Joe Biden? Ugh, there we go. Okay. So of the tabs, I think I managed to keep them all. Some of them might be a little bit worse for wear, but I think I managed to keep most of my tabs together. So the good case will probably go to the good keyboard. And then this one will be our guinea pig. Our $100 guinea pig. Okay, here's the thing. Nobody has ever unplugged this plug before. It has been plugged in using the plastic. It has not been unplugged. And so it is an extremely tight fit. What I'm going to do is I'm going to take my pin tool, if I can find it. My pin tool, there it is. And I'm going to actually work the plastic of the plug out because this risks pulling wires out. The crimped interface in here is not very strong. You know, it's as strong as you can get a crimp to be, but it's not really going to hold up to the amount of force that we're going to need to unplug this. So I'm just going to push on it from this end. So I'll move a little bit there. See, as soon as this thing lets go, I'm going to end up raking my hand across all these through-hole parts, which is really, really painful. These are like little daggers. This has a different, wait, does this have a different processor than the other one? This looks smaller. That's a problem. Trouble number one. Actually, no, maybe it's the same thing. I sure hope so. What is the date on this thing? 2022. This one is... What year is this thing? There's no date on it. Huh. Yeah, it's got Rojas 1846, whereas this one just says 2022. Huh. Yeah, we might be dealing with board revisions. That's gonna really mess me up. You know, if they did a board revision, they could make it survive getting spilled on, at least. Well, you never know what you're gonna get, especially with this show. You watch out, bother. You never know. Never know what's gonna happen. He could explode. What the hell? Why isn't this man, this thing is tough. What's going on with this? How can I unplug it without tearing my hand apart? There's like a tab on top of it, but I don't think that tab does anything. I think it's there for just to kind of be there. I don't know. There's like a keyway. There we go. Twisting a screwdriver on that thing is the way to go. All right, man, you're just a 5-pin plug. What business do you have being so impossible to unplug? God, that thing was locked in, ready to fight. All right, let's take a look at the board a little closer. I mean, everything is roughly in the same spot. I think maybe it just feels like, whoa, what the hell is that? Ugh. Yeah, it's actually just the pads. We were assuming QFN, whereas this thing actually has a QFL, I guess. Quad flat lead. That this thing has leads on it, so that's what differs from the other one. There's not much of a difference other than the fact that this one is 1846, whereas the other one has the year. I don't think this keyboard was manufactured in 1846. There is a 2018 in the part number, although there's a 2018 in the part number here too. Oh, same part number. Same part number, so they are the same design. This is not a revision. Mischief Officer. Oh, glad it comes with a title. Man, in 100 by 100 millimeters, we've got all the space in the world to work with this thing. So this is where I put the button, because the button is the reset button for the microcontroller, and we don't need to have some dip telling us what to do. Those just go to resistors, and then they make their way down to the main processor, which I'm trying to get on camera, but everything is in the way. Hold on, let's move back a little bit. Everybody move back. Everybody move back. There we go. So it's a Sonics. And the part number I have from our old keyboard shenanigans. Sonics SN, hold on. SN8F22. Yeah, it's the same thing. 8BFG. 88BF is the model number that we have here. So we already know what everything's doing. No chance of just replacing the original microprocessor. Do you work with Sonics? I don't work with Sonics. I barely even know anything about Sonic. Some of my friends are into Sonic, but like people are crazy about Sonic these days, and there's like porn of it all. And it's just weird. Like there's Sonic and Shadow, and then what, Amy and what's the other one? Tails, Knuckles. I don't know fuck shit about all Sonic. I don't know anything about it. And especially not Sonics. It's some fucking fan came up with their own whatever. So I don't know what it would take to repair or fully fix this thing. I could take a gander and maybe replace this 12 megahertz clock that it runs off of, but I would rather have QMK because you can do so many other cool things with QMK. And I can add a screen to it and all that. There are the QMK people, or somebody is looking at taking over this microcontroller, right? Sonics are generic 8051 IC based guys. You need to code your own QMK. I think people are working on that. I think somebody was working on that. But in the meantime, it's easier for me to design a PCB, and it's a lot more fun. Because I don't know what went wrong with this. I don't know what went wrong with this. It could have been the Sonics microcontroller could have died. It could have been the crystal getting stuff in it. it certainly looks brand new from here, but when I plug the thing in, nothing happens. But yeah, we've got your basic, you know, microcontroller setup. Here's where the reprogramming thing fits in. It's got these two little locating pins, and then this will reprogram this microcontroller or this microcontroller. And it turns out, I believe this one has the wherewithal to reprogram this one. So it's kind of like a default backup. It'll reprogram the other microcontroller. Pretty crazy. And then in the meantime, it just works on lighting applications. So I think in the grand scheme of things, we're going to want our orange flexi-PCB to interface with both this one and this one. What a pain in the butt. Maybe a fuse blew. Man, like, come on. Come on. What are we going to do? We're going to sit here and troubleshoot this thing all day? No, we're going to design a PCB that'll go on the thing. Does this look like a fuse to you? Any of this? I guess maybe that's a varistor. This is called var 203. I could check continuity in it. Seems that voltage comes in, voltage goes out. You can't explain that. Goes to two sides of a capacitor. Is it a capacitor? RLR. RRCC. Enter. RRC. CR. Looks like a K, but there's a V. L202. So inductor, varistor. TP202, that's the test point. CC, so capacitor, capacitor. And TP201's right there. That's your 5 volts in. MCs. We went through a lot of effort to trick rocks into thinking so that we could blow them up as a fuse. It's like a dark star. Oh boy, that's a deep cut, bother. I have a sentient bomb. Okay, so yeah, we have 100 millimeters to take over all this stuff. So we got plenty of room. And I've got space up here where we could put the microcontroller. Oh, so these are the controls for the RGB LEDs. It looks like there's a little bit of dirt there. It's like most of the electronics in this thing survived perfectly fine. I don't understand why a little bit of liquid and this thing goes completely, you know, AWOL. Why does it die with just a little bit of liquid? I mean, geez Louise. At one point in my life, I did conformal coat one of these. It runs really fast because of the name. Yeah. I didn't do any troubleshooting, and I don't plan on doing troubleshooting. Did you see my other keyboard? I'm not going to troubleshoot this fucking circuit. You guys can go kick rocks. I'm going to take every piece of peripheral capacitor off of this thing, and I'm going to solder a thing in there. So these two pins are going to be carrying my USB to two pads that I will then solder to either the test points or the pads on this side of the circuit board. I mean, I could even leave a little squiggle that I would pick up and then put down on top of this. All of these would solder to one side. And then on the flexi-PCB, we would have like a squiggle piece that would then connect there. And so that we could connect these pins to these pins. And of course, all the surrounding stuff. It wouldn't be on top of each other though. We need to move this off somewhere, you know, in the immediate area. So okay, let's take a look here and see what we can find. So we have a part number for this, by the way, and we have a part number for this, so we can look up what the pin spacing is and everything. Try to get that right. I don't know what kind of tools there are in Fusion 360 for doing flexi-PCBs. I don't know if I can do like, we're gonna discover this together, but I don't know if I can do like specific measurements and sketch lines and stuff. It would be nice if I could figure that out without having to do coordinates, but we may end up having to do coordinates. Hey, stop kicking my rocks. Stop it. All right, so Fusion 360 we have open. My next step is to open GrabCAD. I don't know if there are better PCB designs, but GrabCAD typically works in Fusion, so I sort of gravitate towards them first. So if I go to GrabCAD/library and I search PicoPi, somebody will have made a dimensionally accurate PicoPi. That was easy. This is the W. I'm not using the W, so maybe we can find a slightly different one. I like it to have a particular look, which is not this. See that? This is perfectly acceptable in engineering. It's totally fine. Nobody will get hurt if you use this part. But I would rather it have a look of having all of the components on it. So this one's pretty good. It's pretty simplistic, and that's all we really want. We can get rid of the headers on the side. Oh, it looks like they did it for us. So that's a pretty good model. This one is probably the more detailed of the models, though. This one has all the components on it. Not that we're going to need to work within all of the components, but does this one just have like baggage on the end? Without that wireless thing? I guess it's just got like a big open area where they're free to, well, it also has 3 debug pins on the bottom that aren't in this model that we're looking at right now. Although I do like to have all of this stuff in there. It just looks better. Well, wait, did this person make a, what else have you made? Oh, you snob. This snob only uses the wireless version. The microcontroller that I got, I ordered right away. And so it's sort of like the first revision of the RP2040. So I don't know if we'll have, wow, purple Pico clone. Whew, that's a lot to look at. This would probably be perfectly fine for designing. This too. This one isn't quite what I've got. Those chips are a little different on the end. We've got, oh no, they're not. Wait a minute, this is what I have. Okay. I mean, yeah, this is probably fine. This one's probably fine. Let's get this one. Oops. Download files. Oh no, I gotta log in. All right, let me log in. Dude. It's Hunter 2, right? Yeah, that's what it is. Okay, let's download that. Ooh, they got motors. Okay, so go to our downloads. Oops, no, I don't want that. I want the, lost it. Open there. There you go. Raspberry Pi Pico snapshot, extract to folder, Pico, and then Pico without pins because we're going to be using the edge pins for it. We're going to have to make a footprint for this thing too. At some point in your electronics journey, you realize it's not worth making your own MCU clone unless it's drastically different, for me at least. I don't understand why, yeah. Just put a wireless Pico in and do Bluetooth keyboard. I'd have to add a power management IC, and I don't really want to do that. I don't really want to do that. And you could play with QMK and probably make it do all kinds of cool stuff. But I don't mind wires on my desk. I'm going to minimize the wires on my desk, but I don't mind them. I like the peace of mind of not having to worry about it. And I know wireless keyboards are great these days. Like, you have to charge it like once a year. But I just, whatever. I don't want to deal with that ever. So anyway, the lived-in look. All right, so let's get the model into Fusion, and then we can make an electronics part that's going to represent our Pico Pi. And that'll be sort of our initial foray into this design. I've never done an orange flexi-PCB in Fusion before. I've never done an orange flexi-PCB before. So this will be interesting to learn. I'm going to have to figure it out. So 3D part models without a library thing in there, or do we just put it into 3D part module? This is the one with the pads. This is the one that goes into the library. 3D part models. Those are part models that don't have pads. And then 3D part no library is something like a panel mount button. So these would be things that, well, that one's in the wrong folder. But something like these magnetic connectors, and I don't know why these are in there. Those should be in the other one. Something that you wouldn't typically give like a footprint to. And some of the spillover stuff. Well, the microcontrollers are in here. What are they doing in here? All right, part model. Let's hit upload. And let's get that folder up here again. I am a proponent of drag and drop. I know people love their consoles and they love their file browsers and stuff like that. I don't know. I like my drag and drop. I'm weirdly, that's old school, but it's not as old school as command line. I wanted to make my own cheaper Arduino at one point and then thought about it a while and thought, why? Arduino is at least easy enough because all you really need to do is give it a clock, and then you can use the entire microcontroller to do everything. In terms of the RP2040, and the reason that I'm using it is because, I mean, look, we got a nice voltage regulator on it. It has some memory on it. It's got that clock sitting over there. It's got, I don't know, it's got text. There's probably, well, actually, it doesn't look like there's a significantly larger number of pins if I interface directly. But then I also don't have to deal with soldering that. That looks like a lot to solder. So it's just easier for me to use this thing because I got this for $5. I got it for $5, you know? I can order the chip directly. I don't know how much they cost, though. I want to find out. Hold on. RP2040 chip. Buy a RP2040. I want to buy a RP2040. Buy now. I want it from Micro Center. They don't want to sell me it. For fuck's sake. How much does it cost? Maybe return within 30 days. Why are modern commerce sites like this? Why are you like this? Can a kit. $1. Oh, that's actually kind of nice. It's a $1 chip. Yeah, I can do it with hot air, sure. You know, it's fine. But I don't think I'm going to be putting the chip directly down. I mean, it would be kind of cool to be able to do that, and it would sort of integrate within the keyboard a lot better. If it's only $1 per chip, but then I need the clock and I need other stuff. I need the voltage regulator, I need the clock, I need all that other crap. I guess this microcontroller is a 5-volt microcontroller, isn't it? The one that's originally in the keyboard. Interfaces directly with USB, and there's really no provisions here for voltage regulation. We got to be careful about that, because the RP2040 is 5-volt compatible, right? Actually, to be fair, we probably could just make an adapter. That'd be kind of cool. It would certainly lighten up the circuit board, but it would be a lot more work for us. So I think I'm going to stick with the whole big RP2040 setup. I think I'm going to stick with the big board. So yeah, I've got the board. It is in this folder. Let's take a look at the 3D model real quick before we move on. Bada bing, bada bingus. Oh, I see. When the modules have pins on them, I put them in this folder. Well, this is fine. This is fine. So this is the model that we're going to be pulling into our pads. We're going to make a bunch of pads that will represent this thing. I don't know if I need to include the holes on the 4 ends if this whole thing's going to be soldered down. But we got to make this into a part. We got to make this into an electronics part. So I need to actually get into the library editor. Not new electronics library. I guess I can open it using the, I can get into a different design. I can start a new design. That's essentially where we need to go with this. So what is this going to be? It's a stream project. Oh no, these are single use. Oh, but the bevel's here too. So let's put a new folder into stream projects and let's call this code QMK takeover. And this, I'm actually going to move into that. What? Where the hell are you? Stream projects, code QMK takeover, move. Okay, so that's in there, part of this whole thing. And then we're going to do a new electronics design. I'm going to save that. Code QMK PCB. All right, so now I can actually do a new schematic. It'll eventually figure it out. Come on. And with the new schematic open, and go to place the component. What I'm going to do right now, it's displaying all libraries in this big orgy of parts, and we don't want that. We want to kind of compartmentalize things so that we can process them as humans instead of actually having this giant list of a billion parts, all the parts that I've ever used, right? Okay, I haven't lost any chats in the fray. Let me make sure that my YouTube is updating. Yeah, I think I could totally handle soldering the RP2040, and it probably would be the lighter thing for me to do, is just to buy the 2040 and throw a clock at it and just use it that way. But there's also that built-in voltage regulator that I'm using, so maybe I should just stick with that. And that way I've got everything that I need there. I don't have to design a voltage regulator. I don't have to do all that other stuff. I could use an LM1117. That generates a lot of heat compared to what the RP2040 has. So this thing is my one-stop shop. And I dropped it. I dropped my one-stop shop. No, but yeah, this is the one-stop shop to get all the stuff that I need down on one board. And if this thing breaks, I've got others. Maybe one day we'll do a native RP2040 project, but this is not that time. So anyway, I don't want all my libraries. All I want is my 2018 libraries, the ones that I've got. Well, basically they're marked in use on this thing. Because like Fusion comes with tons of libraries, and I'm sure the parts are great. I just don't know if I trust all of them. And I've imported a lot of stuff, and I've made a big mess of everything. But having three-dimensional parts associated with your library is very nice. And so I've been trying to keep that up by maintaining my own specific library. So if I click in use, these are the ones that I specifically imported and improved and have been working on. Except I don't know about this one, the mechanical one with no version on it. That one seems a little weird. Anyway, chips, components, connectors. Chips, components, connectors. Why are there three connectors? Components, generic connectors, specific connectors, mechanical, schematic, and then modules. Modules is what we will be jumping into. So modules is where we're at. Let us edit that library. I'm going to right-click on it. So we went from placing a part, narrowing down the libraries. We can right-click and then edit the specific library. There's probably another way to go about this. You can probably do this through the browsing thing. You can probably browse to that specific library in your folder structure. I can't be bothered to remember any of that stuff. So what I've done is I've gone to place a component. I have narrowed down the libraries to the ones that I've used, and then I'm right-clicking on the library that I want to edit specifically. It's a module library. I've got it in there specifically for projects like this, where we throw modules at a thing and deal with it that way. Edit that one. Edited it. Bada bing. So I call these 2018. They're not from 2018. They're much more modern. What do we have in here? Arduino, Pololu. So none of these are exactly what we're looking for. Here's the RP2040 Zhao. Hey, what's up, Hairbothan? Hairbothan is on Twitch. Okay. I'm not sure if I think my YouTube is doing just fine. We've got the Pololu power regulators. I've got a TNC 3.0, TNC 4.0, TNC 4.1. And actually, we only have one footprint for that. What about the 4.0? Yeah, only one footprint, and then one giant array of pins. So we're doing a new one. Yeah, TNC 3.5, 3.6, TNC IC, all pins. Yeah, I had to do modifications in order to get every single pin out of the thing. So we're going to be doing a new footprint, a new model, a new thingy-majig. It's see here, the Seed Studio Zhao has what we would need in terms of pads. So I'm going to copy what they have and put that down as our PicoPi, as our PicoPi. That's what it's called. So whatever they're doing, because they've got the same types of pads on the edge there. Are they the same size? Hold on. I had an RB2040 in my hands just a minute ago. Where did it go? Where have you gone? Did I put it away? I guess so. Here's another one. These RP2040s are so cheap. It's amazing. You could do so much on them. Did I mention how intuitive AutoCAD is? No, they don't have me. They don't have an ad read. If I had to do an ad read, there would be a lot more money changing hands. Okay, so we are different pins, so we can't really trust. Well, the pin pitch is just about the same. Actually, we probably could get away with whatever they're using. Are they the same width? Probably not. This is probably, yeah, this is a couple wider. We'll have to handle that. I mean, generally, like with modules, you want to make sure that they fit within a 0.1 inch space, spaced board, so that you can use all of your perforated prototyping boards and your solderless breadboards with these modules. I'm not sure who is the violator on this one. Hold on, let's find out. Oops, that's the wrong one. Scroll up, pop, there we go. I'm gonna get a little piece of PCB and we can see who's playing fast and loose with the rules. All the way over here. So what we're doing basically is the initial fact-finding for this project. The initial fact-finding is kind of a really important step. I want to make sure that all my ducks are in a row, that I'm not a crazy person, you know, the basics. Just make sure that all the stuff that I'm doing is viable as a project. I don't want to waste too much time before we actually get into the meat of this thing. Or rather, I don't want to waste my time by getting into the meat of this thing and discovering that everything is how it shouldn't be. I don't know why everybody is so concerned with organizing ducks, but apparently that's what we do. All right, so let's take a look here. And I'll you know, I'm trying to go at a pace that you guys can follow along with without going crazy. So those are 0.1 inch spaced. And they just kind of start to touch the ones next to it. Whereas Seed Studio, okay, so they've got those 0.1 inch spaced, but they're inset a little bit. So is it just a difference of one pin? Yeah, it's one singular pin difference between the two. And those don't line up. Do those line up? The three? They do not. Oh, that's great. We have 3 debug pins, but they don't line up at all. Well, the middle one is ground. That's so weird. Very strange. I wonder what you can do with those debug pins. And then, of course, they don't give you a boot pin external. You can't do the button externally, which is why I went to the other thing. Although its TP6 might be the button, but I don't know about soldering to that. I mean, maybe we could have like a hole in the board that you would solder from underneath. Same thing with these two. Possible. It's possible. All right. So I guess we are good to use those pads. Those pads will be okay, but getting them in the right spot will be a little bit challenging. I think what I can do is cut and paste from one pad to the one footprint to the other. So we need to make a new footprint that's currently, well, we're going to need to make a new component, but the first thing we'll do is make a footprint, and then I can associate a 3D model with that, and we'll be able to drag and drop our PicoPi into it. So, well, I mean, a schematic symbol too, but we'll start with a footprint because it's a little bit more interesting. Hold on. First, I want to actually go into this module, SMD header, and I want to edit it. Duplicate, edit description, rename, maybe just open it. There we go. Okay. So I'm going to steal those pins. Maybe the dot next to it. Nah. We'll just steal these for now. Copy it, and then we'll do a new footprint. And this one's going to be RP, or no, PicoPi. What up, Einstein? Bada bing, bada bingus. So there's our 4 pins, 1, 2, 14, and 13. Where do I want 0 to be? Well, these are in odd spots, aren't they? These are in kind of odd spots. They don't really line up with anything, do they? So this is going to be in a really awkward position, isn't it? 0.835 and negative 0.093. Ay. You could make it a little harder on me. Alt for alternate spacing. Maybe I can get this. That's not going to be good. 0.54 and 0.86. So what is this one then? That's in millimeter. I wonder what it is in inch. Because we're going to do 0.1 inch spacing. You know, we might as well just do this on our own. I'm just going to peek in at the 3D model for this one. So I got a nice 3D model here from Seed Studio. I can go to, let's see, inspect over here. Go from that center to this center. So 15.5 millimeter. Oh no, that's not really going to help me. I'm just using Google. 15.5 millimeter to inch. 610. It should be 0.1, so it's technically closer to 0.6, I guess, which would be 6 rows. God, the keyboard is through hole, so every time I move this stuff around, I'm like poking myself. 1, 2, 3, 4, 5, 6. It's actually 7. Technically, that should be 0.7. So what's lost in translation here? .50 millimeter from center to center. To 2.531 millimeter. 15.5, 14.7. 15.5. 0.610. But like, let's see if I'm a crazy person. Oh yeah, inch. 561. 610. Is my model off? That model might be off. No, but 0.610 gets us. I mean, it looks like it's off by a little bit. Huh. What about the overall width of the RP2040? Nice. All right, so let's see if this matches that. What is that? Pico dimension, but do they have recommended pad dimensions? Because we're going to have to reconcile a lot of different numbers. I'll take a look at that in just a sec. So from this outer edge, we'll go from there. From this leg of the amogus to this leg of the amogus. 17.5 millimeter. .6889. So that's pretty close. So I guess I'm the crazy one here. Oh, no. How do you do this in this program? No, that's not the whole URL. Stop highlighting stupid shit. Oh, that's comprehensive. That's pretty good. It's not the holes, or it's not the pads, but we want the pads to overlap just a little bit so that we can get that nice soldered connection. So from 0.69 of an inch, or in this case, 17.5 millimeter, what does that translate to for the pads? The problem is I don't have direct measurement tools here. I could just, I guess, plot a line from end to end. So that's approximate. -17.43 to, wait a minute, what? -1.27 to 1.27? That doesn't make any sense. That's just it crossing the zero. With this 0.127. So 17.43, -1.27 to 17.43. So it's going to be 7, 8, 9, 10, 11, 4, 5, 6, 7. So 18.7, which is a little bit wider than our 17 point something something. So it's about a 0.5 millimeter overlap is what they're doing. So if we give it a 0.5 millimeter overlap from where the pins are, I guess that'll give us a good solder pad. And again, we can actually see it right here in the dotted line. We can see that overlap. Actually, I can measure it. Wait a minute, I can just do this. There. So 3/4 of a millimeter overlap, actually. 0.725. So let's plan for that. Let's plan for that. So if I take the 3D model of the Pico, and we'll have 3/4 of a millimeter overlap. So we want the outer edge of that pad we'll just do it at positive and negative half of, oh, positive and -7 to get to the 21 millimeter width. Although we need to calculate this whole thing. So it's going to be, okay, so that's neat that it works out to a nice even number. That's the wrong project. Okay, so let's go over here. Let's just mark this down. So 21 millimeters, and then we want our pad to come out by 0.75. And then how far back do we want the pad to go? And again, these are different pads. So they're going to have different, do they run the same distance? They kind of don't. So we'll do our own custom and we'll have it run all the way to the back of this thing. So it'll be 0.75 plus whatever this does. That's in inches. Come on. 2.5. 2.3. So let's mark that down because I will not be able to remember all these numbers. Keep opening the wrong one. Where is it? There it is. .32. And so we basically want a pad that's just going to cover all of that. Hold on, let's do this. Let's put an actual thing in. Way too thick. Line on it. Oh, no, escape was not the button to hit. .75, and then I want this to come back, what, like 2.5? So that puts the center in kind of a weird place. Where do we want the center to be? That's going to be in a weird spot. I'm trying to get a feel for the coordinates that we're going to be using here. What do they say on the data sheet? They said 2.4. Okay, well, we'll go with their number. It's an easier number. 2.32 is coming from my calipers. And they don't have a suggested pad, I don't think. So we've got 2.4 plus 0.75. We'll take it out to 2.5. It'll be a little bit wider out. So 2.5, and then edge to edge is 21 millimeters. So what is the center of that thing? 2.5, 0.75. This is adding up a change in my pocket. .5 plus 0.75, so 3.25, 3.25 millimeter. .25, and so it's 1 point, oh God, what's half of 0.25? Divided by 2. 1.625. Although if I put 0 at 0.75 millimeter in there, I got to take that 21 millimeter. Oh man, I do not know. This is very confusing. This is where those sketch lines really come in handy in the fusion stuff, because we're basically trying to figure out what the coordinates are for the pads. And these might be a little bit wide. What's the width of this thing? 2.75. We were going to do 3.25, and then there's our 2 millimeter wide. So we can stick kind of within those. Wait, we can't customize it? Yes, we can. It's actually 3.25. And let's get rid of this. And then from there, it would be, oh good, the centers are different too. All right, let's see. First of all, let's just set this one to 0, 0. This is our OG coordinate. So from 0, 0 on the center of the pin, the edge is how far away from the center. The edge of our board, that is. And that way we can calculate where the other center is supposed to be based on the 21 millimeter width of the whole thing. It is a weird, circuitous, strange logic that I subscribe to, but I'm here for it. So off by, we want to move so that there's only 0.75 left. So this is 3.25. So it would be 1.125 that way. Ah, my brain. 1.125 minus 7.5. .375 over. So we want minus 375, negative 0.375. So we're subtracting from 21.375. .625 is the location of our other pin. So that's going to be 20.625. And I am going to save this, and then I'm going to pull the 3D model in, because I can't be trusted to do this properly. I'm going to take every weird shortcut in the book that I've got, and we'll see whether or not my calculations are correct, and if these pads actually line up to the 3D model. And then we'll worry about doing the rest of them, because we can actually lay them out in a pattern. We can use the pattern tool. So let's do a create new 3D model. I'll call it PicoPi, and then I'm going to go into the stuff that we've been doing. We're going to go into admin project, 3D part models. I'll scroll down and find our PicoPi. There she is. And just drag that sucker in. Ba-bam! And of course, it's not lined up properly because the center of the PicoPi is, of course, the center of this thing. But let's just drag it onto a couple pins here. See if we've got 0.75 off of each end. Looks kind of close. Let's just do a measurement just to see. Boop. Here. Here. 1.125. Well, hold on. It may not be. Oh, wow. It's off by a lot, actually. It's off by a lot. What is this one? Okay, I didn't need all that. I just need this to this plane. 1.75 and 1.125. How do I center this thing between these two? That's not quite what I wanted. That's a full millimeter of runout, which wouldn't be too bad to solder, but I mean, it's just, it's a little excessive. They need to be moved in a little bit. They're not quite, yeah, my pad is sort of in the middle of this. Would it be, because if I center it and I move them 21, then it's not quite, I think about this a little bit. Dimensional stuff is very confusing. All right, let me get out of the 3D part editing thing and without finishing. Don't save anything. Get me out of here. All right, I screwed it up. I screwed that one up. Edge to edge, 21 millimeter. We got 0.75 on either side. The center is 1.125 because we're 3.25 wide. Should give us enough. Okay, 3 point. What is this dimension? I'm so confused. So we're going from the center, which is 0. Center is 0, and we want to go back a certain distance in order to locate the edge of our board and have it be 0.75. And then from that point, we want to go 21. It's like, this would be easier if I had sketch stuff. Oh, we're not editing this yet. Go back into editing it. Oh, no, that's not what I wanted. No, close that. We are editing it. What am I talking about? What am I talking about? Think about this a little bit. Hold on one sec. So 0.75, 0.75. So it would be 21, 22.5 to go outer edge to outer edge. 22.5 minus 3.25 is center to center. So it'd be 21.5. No, 22.5. 22.5, because it's 0.75, 0.75, so that's 1.5. 0.8, what am I? 22 point, no! 22.5 minus 3.25. Because that's half and half. So I want to move 19.25 so this one would be 19.25. And that scoots that in significantly. All right, let's try that. Let's save it. And I'm going to go to PicoPi in where, oh, you've got to wait for it to. Oh, we're in the 3D. I want to be in the 2D because in the PicoPi, I can do create new 3D model. Hopefully that saves over. I don't know what it does to that. There might be a couple Pico Pis that are unresolved as a result. Pull this in. Hey, what's up? I'm sort of like floundering with this in a way. What are you building? We're going to try to make a flexi-pcb because they're so cheap now. We're going to try to make a flexi-pcb that will allow me to QMK my keyboard, my code 10 keyless. We did a lot of work into this in the past. This looks like it's actually going to fit. I just don't know how to locate. I don't know what object I can locate this on. Actually, what I can do is go edge to edge. Edge to edge. Ooh, how am I gonna, it's tough. Basically, I spill shit on my keyboard, and so in the past, when I spilled shit on the keyboard, it's broken the keyboard. And so I did a comprehensive rewiring in order to turn this into QMK. And it uses a Raspberry Pi Pico and a bunch of jumper wires with some muxes in order to get all the signals from the chip into the Pico Pi. Instead, what I'd like to do is design a flexi-PCB for this other dead keyboard, the same keyboard, now that I know all of the pinouts, and make this cool flexi orange PCB that will be able to basically just solder into a code 10 keyless and take it over, make it a QMK keyboard. I think people are working on rewriting the processor to do that, but in my case, the processor is dead. So we're just replacing it. Can I go center on this? Where's the attachment point? If I go point to point, yeah, see, there's the center. I think this is the center of that. If I go to this center, I don't get a center for this. Holy hell, this is obnoxious. We'll go there, but then I'm going to move it a millimeter down because these are 2 millimeter wide. -1, okay. There we go. It's like we're home. And is my 0.75 intact? I'm doing everything to avoid doing actual math. 0.42, is it even on both sides? No. Thought it would be even. See if we can get that even. 1.08, 0.42. I see a fun project. It's a lot of this is like theory blasting. We're just blasting theory at it. Work distracted me for 40 minutes. What did I miss? My utter and complete incompetence and my insistence on avoiding any form of math. So one's 0.42, the other's 1.08 because I centered it on the center of this, and that was a mistake apparently. Even though that probably should have put that in the right spot. To be fair, I guess what I could do is I could measure center to center, which is really all I want. Let's do center to center. Yeah, let's do that. Okay, so measurement tools, and then I want to look at, where's the, oh, show snap points, boop. And then there's this center. This is sort of the center of the assembly. Hold control to preserve all of these points as you hover over the thing. So that's the center of the hole. I don't want that. I want the center of, well, this whole amogus. But that's not really going to be, don't I want the center to lie somewhere around here? So maybe that's where we went wrong. That's not really, I don't have a good like reference to go by on this. Yeah, it's all about avoiding the math. So what if I take this to 0.75? Let's just go and measure from here to here, and then we'll take that to 0.75. So 1.08. So 1.08 would it be 0.75 minus 1.08 or the other way around? Let's add to this one in order to get it to be 0.7. God damn it. I'm so dumb. I feel so dumb right now. Okay. The thermal camera is, there's actually a command for it, and it's a Lepton 3.1 thermal imager that I made my own 3D printed enclosure using Fusion 360, I made my own 3D printed enclosure. Lepton has all of the 3D models for the camera that includes the vision cone, the cone of vision of the camera. So I was able to actually just extrude a solid over it and then have it just cut it out. Is this PCB software free? Yes. But the free version has limitations on it. And you can work around the limitations. You know, it's it's not that difficult to work around the limitations of the PCB software. But it's called Fusion Eagle, although this is AutoCAD Fusion 0.42. I've found AutoCAD Fusion to be a very pretty program, and I know how to use it. I've known AutoCAD all my life, and it's pretty. It looks really good on stream. And I can import all these wonderful 3D models from like GrabCAD and places like that. I can make them look nice in sort of a slightly simplified engineering drawing. All right, so we got to move this thing to make 0.42 into 0.75. 0.75 minus 0.42, 0.33. So move this that way, negative 3.3. I'm having the damnedest time. I am having the damnedest time locating these holes because they're amogus shaped. I'm a CAD noob. I work in games. Do you know Blender at all? The thing about AutoCAD is it's a little bit different from your like games CAD because you're working with comprehensive sketches. You sketch everything in 2 dimensions and then you extrude it out. And then from there you can chamfer it and stuff. Basically, the mantra with CAD is you want to be designing your solids in the same way that you would be building them in real life. So if I was going to use subtractive manufacturing, like a milling machine, I would start with a block and I would whittle that block down into whatever I'm trying to make. Although, you know, CNC and stuff like that has become so capable these days that you don't necessarily need to strictly follow that mantra. But that's generally how I do it because I like to think about how this thing's going to be made. It's a little different with circuits and circuit boards, but with like 3D printed solids, it's really nice to start from a 2-dimensional sketch and work your way out because that's how it's going to be built. If this is 0.75, I'm going to be happy. If it's not, I'm going to be sad. This thing has a lot of agency over my emotional state. Damn it. It's getting a little weird. It gets a little squirrely about what you're highlighting. That is incredibly not what I wanted. Okay. That and that. Now we get a flat. Ah, we got it right. So, what was it? 19.25 locates these 2mm pads appropriately. We can probably narrow it up a little bit, but I just didn't want to mess with it. What up, Mahalo? How you doing? Okay, how many pads do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The 20 by 20. So with 20 by 20, what I can do is I'm not going to save this. I'm going to, well, actually, maybe I should. Maybe I should. Go over to package and hit finish. And then we go back into the 2-dimensional one and we can add all those extra pads. So pin 2, I can actually get rid of. I've got the number sitting right here, 19.25. And I can do, click on this one, and then I can go into place pattern, square shape, 2 columns, 20 rows. There we go. I want it to go down like that. And now the spacing for X is going to be 19.25. And then for Y, it's going to be, what is it, 2.54? Or is the, let's check what they say over here for our center to center. Amogus to amogus is 2.54. That's going to be a little tight. I'm going to have to make these a little smaller. Oh, and it numbered them, stupid. It numbered them, stupid. Oh, what a joy. Hey, what's up, Brian Labs? How you doing? It numbered them, stupid. Control Z. Okay, try again. And this time we're going to take our width and we're going to make that a little bit less widthy. Let's make it a little less girthy. What's our girth? 1.6. So let's minimize that because who knows what traces are going to run where. We'll make that a 1.6. So 3.25 by 1.6. Little less girthy. And now we're going to do a pattern. Do I have that in this? No, I don't. Place pattern. Let's get all this junk out of the way. Hold on. There we go. We're a little bit more centered. Hey, what's up, Tim? Pattern. Bonk. Columns 2. Rows 20. I wonder if I did it the other way, if I didn't do it vertical, if it would number it better. Like if I did 20 columns and 2 rows, but I've already got this thing facing in this direction, so. Yeah, that doesn't really fix it. Start point 0, 0, 2.54, and then 19.25. Double check my number in the calculator. 19.25. Yep. I wish I could have it actually number them appropriately because I got to go through all of these individually and now renumber them. That's kind of obnoxious. What if I just do columns 1 and then it'll number them properly? And then I do this, and then I do place pattern, and I do 2 columns, and I make it 20 or 19.25. That's upside down. Can I flip the Y direction? No. '21's supposed to be here. Why did they not give us provisions for that sort of thing? What the heck? What does that even do when I change the... It doesn't seem to do anything. Start point is 0, 0, and then... Oh, I see. That puts it in the middle there. Okay, so let's do, yeah, like that. But then can I flip it without causing a ruckus? That's very annoying that it wouldn't let me flip the numbering. What if I do -2? No, doesn't let me do that. It does not let me do that. And that just lets me do the X direction, but it won't let me reverse the numbering. Well, let's see. Done. Highlight it. Nope, that doesn't line up. Hit that with a Control Z. All right, so let's just, I guess, go down the row. So actually, we need a junk pin first. So I'll get rid of 40 and make it 88. Order 66. Yeah, there you go. So now 40 is free, and I can go 40, 40, 39. Oh, ah. 21. How do I do this so that I overwrite the pin? Because if I make this 22, 22 already exists. So there's got to be a way that I can do this in order to make it work out properly so that I can number these without getting in the way of each other. Maybe there just isn't. Can I... Is there a tool for this? Well, it would probably be a ULP, a user language program, if there was actually a copy format change, and then I've got with thermals pore ratio rounded D-type unit, blah, 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 blah. Align, cap, no cap, diameter, D-line, D-type. I guess I just got to go back and forth with it. 21. I was going to add a 2 to all these. This is really annoying. Can you flip or mirror the selection? I can, but they don't really line up properly. Whoa, okay, let's not drag and drop. Where did the pin go? What the heck? I'll need to do this for half of them, but... Weird. It's just weird jockeying stuff. It's like busy work. It's kind of annoying that they didn't let me switch the number schema, like how it came up with the new numbers. Three, 4. There's a lot of busy work in making a new part, but this will allow us to place our PicoPi down on the FR4, so or on the Captain. I don't know. I forget what that stuff is called. You know, there are some helper things that the program does, like and it's done it as far back as when this was Eagle and not Fusion. It would increase the number every time you click on something. And I guess I could use the change tool, but I didn't see like a pin number in that. So like I can right click. No, where is it? Modify, change, line cap cream, diameter, D-line, drill, D-type unit, fish font, font family, join layer, pore ratio, roundness. These are mostly physical board things. They're not, they're not style, text, thermals, and width. There should, I mean, somewhere in here, there should be a pin option. It's weird that it's like the physical board layout ones and not like pin swaps and stuff like that. Usually the change tool is good for that sort of thing. So anyway, I'm forced to go through here manually. $29. 30. I don't think I'm going to represent the debug pins in this. 1. And we'll make the USB input just 2 pads. That'll run wires too. Yeah, by the time I'm done figuring out what tool would make that faster, I might as well have just manually entered it. 34. 5. 36. I should do a game stream tomorrow, but I don't know what's going on around here. I would like to do at least a back-to-back this week. We've had a lot of family stuff going on around here, so there's been a lot of distraction. Willow got a bunch of new toys. He's been tearing apart like stuffed penguins. Oh, that one's already numbered. Oh my god. Okay, there. So that's pins 0 through 40. I should probably give this some kind of a keep out area like the other one had, and maybe just like a silkscreen outline so that I know what the approximate shape of this thing is and which direction to even put it down on the board, So going from this 0 point to however large the box is supposed to be is going to be a little bit obnoxious. How can I get around that? I mean, I guess what I can do is just start with a square outline from a known point and make that our maximum dimensions. So we start at, really, 46.99. Oh, but that goes, yeah, this is going to be weird. You know, I guess I could design it around 0 and then select the different pieces of it. So if I just start it here, and then we can shuffle it out of the way when we need to. Will that break off from, yeah, I'll have to figure out the math on that one. That's going to math. That's going to be more math. Okay, so our width and height of the overall board will go by what the datasheet says. Entering numbers into computer. 51 by 21. So that should be positive 21. This one's 21, and this one's negative 51. And there is our outline. And we need to get this, what was that number again? From center to where it needs to go is, oh, I forget. Oh, but we have, wait, we've got all kinds of numbers in here. We have all kinds of numbers in here. So if our 0 is on this thing, and it's 19.25, our first point is going to be negative and positive, and it's going to be, well, it's 21 minus 19.25. 21 minus 19.25. 1.75 over 2. 0.875. What the? 0.875. So we need to be negative 0.875 instead of 0. But that's going to move the other one. Do I have a move tool? Yeah. Oh God, it's horrible. I forgot to select one of the things. Ah, what in the? Stop it. Done. Oh my God, what I wouldn't give for some centering tools here. See, I don't even know if that's accurate or not. Just because I just moved it within the grid. It's not necessarily where that is, where the outline of the component is going to be. That's the tough part. I mean, it looks relatively even, but I bet it's not. Oh, no, it definitely isn't. What can I do? How can I get this right? Because that center of the pad is not necessarily going to be the center of the thing. And so if I take 19.25 21 minus 19.25, which is what I did, I get 1.75, and I get 0.875. So this line should be at negative 0.875. So let's make that happen. This kind of stuff drives me nuts, and it's really why I wish there were proper sketch tools from Fusion, from AutoCAD in Eagle. So then this one is going to be, that one is negative 0.875, which means to get to 0, oh boy, 0.875 to 0. But that's part of the 19. So it's 19.25. minus 0.875. 18.375. Is that right? That looks like it's off. Yeah, that's way off. Why am I so far off? Oh, because it's 21. It's not 19.25. It's 21 minus 0.875. 19 is the pad spacing. 20.125. That seems wrong. $20.125. Oh, that may be correct. All right, top and bottom spacing from these pins. How can I reach these pins? So the center to the edge might be something that they give us in the data sheet. Let's just check. Center. Well, 48.26, so 51 minus 48.26 over 2. Unless they give me exactly what I'm looking for. No, they don't. They don't. They never do. They give you weird numbers instead. So we get 51 minus, that's plus sign, 51 minus 48.26, 2.74 over 2. So the top line should be at 1.37. Well, it's close. We're off by 1/10 of a millimeter. So I guess what we can do is 3/7 that, and we can 3/7 this one. Oops, 1.37. So we 3/7 those up, and then we move this one up by 1/10 of a millimeter too. So negative 49.73 would be 6.3. Because we're moving them both in tandem with one another, and this should be a 51 line. Double check the math. Negative 49.63. So 49.63 plus 1.37 is 51. Hey, look at that. Our numbers, the numbers match. The numbers match. The numbers are the numbers. The numbers never lie. They just disappoint and frighten me. Okay, cool. So that is our outer board width. A little irresponsible of putting a silk screen on top of a pin, but it's what it's. I mean, maybe instead of that, I take those coordinates and I make that a keep out area. It's not easy to love math. It's not easy. Yeah, because maybe I'll do just like a different box inside on the T place. I come all the way out to here. Let's go this. And that'll actually be representative of the chip there. And then this actually needs to become a keep out zone. But we can take the coordinates of that and figure that one out. So it's actually these coordinates down here. Well, actually, no, it's 1.27 up. And then how many in both directions? Okay, so I'm going to write these down just so that I don't lose them. That is the wrong paint document. Negative 0.875. Get this out of the way. Negative 49.63. This is like math torture. This should be against the Geneva Convention. I really wish I had better sketch tools is all. 20.125. And then it was 1.37 at the top. 1.37. Oops, I was hitting. $1.37. It's a little pixely, but the numbers are there. That's all that really matters. I'm going to hit save on this thing if I can. Can I save this? Ah. Save as. We're putting it on the desktop. Calling this new folder. Keyboard Revisio. I need to get into my file server and deal with the any transparency will be lost. What? Yeah, just what? Is this a new project? It's a new old project. The old project was to get my keyboard to speak QMK, and that was a rousing success. And then I shelved it in perpetuity because the one keyboard worked just fine, and I purchased the backup keyboard because when you're a streamer, you got to have backups of everything. So having a backup keyboard is very important. And so this was temporarily fixed, and I had a backup, and then I spilled like a thimble full of liquid onto the backup, and it broke. So now this one is broken, this one has QMK. What I'm trying to do is design a PCB that I can solder down to these pads and have it be a takeover PCB for the code tenkeyless. Because we spent a lot of time and effort and blood, sweat, and tears into getting the layout of reverse engineering the layout of that keyboard and getting it working in QMK. So yeah, I really want to do an orange flexi-pcb because it'll be fun and funny. Let me just get the pad spacing down. It's pad, and then pad, doot, doot, 0, 0. And this one is just so that I have it. $19.25. Control S. Okay. A lot of calculations going on. So now I guess I'm going to get rid of the water wings here. And we're going to replace it with an actual keep out zone. How do I do that? First of all, I'll save this. And I'm going to take a look at the other one. Why do I have multiples? Oh boy. I'm going to have to reconcile which one of these is which one of these. Picopi. Oh yeah, it's like one has pads and the other doesn't. Let's get rid of this one. Delete. That's just the one with the 3D model. Okay, so back over to here. And it would be top keep out. Which one's the red? T keep out. Properties. So this is just a rectangle on the T keep out layer. Why there are additional rectangles is beyond me. I guess this is a keep the solder off of this. Huh. What's going on there? T restrict. What's the difference between keep out and restrict? And those are just top. Okay, so T keep out. And oh, no, close that. So we want to jump over to ours, which is pcop, but it's the footprint, not the, we want this. And then we want to go to keep out. Okay, our layers remain the same. And then I want to draw a rectangle. Draw me a rectangle, if you dare. And the rectangle is going to go to the coordinates that we have specified. Properties. So it's going to be negative 49.63. Instead of 0, it's going to be 1.37. And it's going to 20.125. And then negative 8.75. 0.875. That should be the outline of our PicoPie. It's not. Wait a minute. One of my negatives is supposed to be positive. .875 is this direction. 49.63 is that way. 0.875 is that way. What do we, 1.37 is supposed to be the top. That's 0. 1.37 should be up here. What kind of silly game are you playing on me here? I got the wrong numbers in the wrong spots. Oh, here's 1.37. I mean, negative 0.875. There we go. No! Why must you do this to me? All right, new rectangle. Start it vaguely in the right coordinates. End it vaguely in the right coordinates. Look at the numbers. Negative 49. That one's as clear as can be. That one's at negative 50, so negative 49.63. Which is what we got. That's what it said. From to, I wonder if it's from in distance. Negative 1.75 should be negative 0.875. 20.32 should be 20.125. And negative 49.63. And then this one, 2.54, should be 1.37. Okay. And it's perfect in every way. Yes. Okay, there we go. That's more like it. Did you get any promotional codes for the Fusion? A buddy needs a new subscription. I didn't get a promotional code, actually. All they said is that I get a free copy of the software if I do basically what amounts to 2 streams a month. I could tweet a whole bunch of times as like a sponsored AutoCAD thing, and I could get the free copy every 3 months. It's like a certain number, and so 2 streams a month is a ludicrously small amount of time of me using Fusion. Can you ask? Yeah, I'll ask. I'll shoot an email. You could always, if there's any kind of a comment on the order, maybe you could put like Twitch's "Oh Bother" or something like that, you know? Thanks to the influence of "Oh Bother." I don't know, man. That's cool though. Hey, yeah, if you're gonna buy it anyway, we'll see if we can find like a promotional code. We'll see what's going on there. I don't know if I want them to have metrics about how many people I'm influencing to buy their stuff. Or are we gonna put provisions for these holes? I don't think we're gonna put provisions for these holes. Nor am I gonna bother with the restrict layer. It's a little bit too much. You would have done at least 2 streams anyway. Yeah, that's the thing is, you know, I told them it's a very equitable situation because I use this program anyway. I was thinking of getting into FreeCAD. It's a lot of work to switch programs. This is just, oh, hey, oh yeah, Rhine Labs I already got Rhine Labs. It's one of those things like I was considering just dropping down to the free version of Fusion 360 so that I would be able to relate to, you know, for instance, the fellow or lady or fellow or anything in between that came in earlier and said, should I use Fusion 360? And I'm like, I don't know. Like, if you're interested, it's a very good program to use. And sorry, what did they say? They said, is there a free version? And my answer was yes, but I don't know what the limitations are. So I was going to drop down to the free version and use that. And then I would be able to actually relate to you guys and say, yeah, so here are the limitations and what I like and don't like about the free version of Fusion 360. But at just the right time, their creator program folks found me. So maybe one day they're going to kick my ass to the curb and tell me that I no longer get a free version of their software. But for now, I'm part of that, and it's just something that would have happened. Like, I would have used the program anyway. So, but yeah, like promotional code. I don't think I've got anything, but I can ask. I'll ask and see if they want anything. Okay, so for the USB socket sticking out of the middle, the socket width is 8. So we're 4 on either side, but our 0 point is here. Our 0 point is in a very odd place, and it's 1.3 plus that. So we can actually determine where the center of this is using their sketch tools. So wherever this line is, oh, we don't want to be on this layer. Hold on, let's go to the T place to place the tracks, the base. So our center is at, oh my God, what the hell is that number? 9.579833125. Huh? Plus 4. 13.57 blah 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 blah. Oops. Minus 4. No, wait, clear all this. 9 point blah 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 minus 4. That's where we're going. And we are at 1.37. And the USB plug sticks out how far? Where is that window? 1.3. So 1.37 plus 1.3. 2.6. Where's my... What do you mean there's nothing saved in memory? What? Huh? Oh, boy. I had so many good numbers in there. Why is it no longer... Oh, it's in the history. Okay, all right. I clicked the wrong part of the calculator. Okay, so that makes for a box that will be like this. And we'll just go like this, and like this, and like that. Do a little one of these. Hit the properties on that. Actually, we'll do this line is supposed to be at 2.67. Oh my God, what are these numbers? 2.67. This is what happens in electronics is you get these weird cursed numbers. Computers was a mistake. So the subtraction one is 5.579. Oh my God. This number. That one's this number. That is incorrect. It's -4 plus 4 from the point that I got in the middle, which was 9 point blah, 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 blah. It seems a little big. Doesn't that seem a little big for a USB slot? What is the number that we're going off of? It's supposed to be 4 millimeter. Oh, it's supposed to be 8. Yeah, so plus minus 4. 8. That just seems a little big. I guess that's the size. Because if I go from 5 point blah blah blah, well, actually, I go from 13 point blah blah blah. Minus. No, what are you doing? Minus. Do I really have to? Okay, I'll do it this way. 8. Yeah, okay, so that is correct. I don't know why I have to double check myself like this so much. Weird numbers, the reason the US loves their non-metric system. My brother in Christ, I am in metric. I'm using metric right now. We are running off of metric dimensions. It gets really cursed because we have a certain size metric pad and we have a certain size to the edge of the board, and then we have a certain distance from here to here to here. It's like our point, the point that I've chosen as the datum point, is in a strange place. And because of the incredible precision of CAD and the fact that electronics CAD works with an incredible amount of precision, most engineers don't really learn sort of how precise you're really being. I think like more mechanical engineering, more electrical engineers need to be exposed to mechanical engineering, because you're sitting here in a program that's just automating a lot of the stuff that you're doing, and you're getting numbers that are 0.000000 of a millimeter, which is like an impossible distance. It is not impossible when you're etching, but we're not etching. We're plugging it into a software program. It's just that things just get kind of compound cursed as you work with them. That keep out area seems to be wrong. This should be hugging this line, not all the way out here. Why is it so far positive and negative? It's going to negative 52.07. And it really should be going to negative 49.63. Why did it change? 1.27, 1.37. Wait, this completely changed? What the fuck? Hold on a minute. 49.63. 2.54 is 1.3. Yeah, this isn't negative 1.37. This is negative 0.0875. This is 1.37. And then the other one's 20.125. Why did that revert? Must have Control Z in a weird way. There we go. Tighter. Tighter. Do we need to have that as a keep out area? Probably. Let's go to T keep out. T keep out. T cream. Ew. T keep out. Let's see. There it is. I'll put another rectangle in there. Draw rectangle. Close enough. And then I'll put in the dimensions that we calculated, which is going to be cursed. 13. Where's the calculator? 13.57 is close enough. Two digits in the millimeter is perfectly fine. And then 5.57. And then we're going from Well, probably is from 0. Oh, no, it's 1.37 to, what was the top of the USB? 2.67. You got to manually code these. They're not quite good enough yet to match this kind of stuff. So there's our keep out for the top layer. So no components that'll stick up can go in there. Okay, so there's our PicoPi. I guess I could add on the names and values. So T names, and then we're going to drop text down. That would be in document. Nope, not in document. Okay. Place text. There we go. I guess we'll do 1.27, and it's name. I do lowercase. That little code tells it to tells the CAD program to replace the name. So name, and then we'll put on the value layer. T values. Capital value. Name and value. And then I'm going to put a big old dot where pin 1 should go, even though the USB thingy-majiggy should probably be telling us that, you know, you take a glance at it and you look, oh, that one's got a pokey outy bit. That's definitely pin 1. But just in case, I am going to go ahead and, actually, should I just put text there, like on this pin? I can put a dot external. I'll put the dot like right here. So on T place, which is really supposed to be placement guides, I'm going to draw and circle, just like that. I could put it internal like this, or I could bring it out. Let's put it internal, actually. I like the look of that better. So that's just my pin 1 marking. That's it. And everything else should be in there. We've got pin numbers, not names. That'll give us the value for everything. We're not worried about the test points. We just have to keep out of the entire PicoPi. So I'm going to hit save on this. And then we can look at the 3D model. So I can open this up, and hopefully all of those pads will be updated. Yes, look at that. Beautiful. Beautiful. So these little dotted lines are where the actual electronic pad is going to go that's associated with this thing. So the pad goes a little bit beyond this hole here. It's hard to see. You can see it kind of right there. It goes just a little bit beyond the pin, and it is the same width as the pin. It doesn't need to be thicker than the pin necessarily. I think it's okay if it's a little bit more narrow. And it's nice and even on our component. I didn't give any height to this. This is exactly the same height, which is not quite the way it's going to go down, but I think it'll be okay. I think it'll going to be okay. And then there's our USB slot. It's looking pretty good. We can look at that orthogonally. You can see that our dimensions are a little bit nicer than what's actually there, but you know, I mean nicer as in we're being nice and giving it a little room to breathe. And then we're not honoring these holes. We don't acknowledge their existence. We don't give a crap about these. These are unnecessary. We don't care. We don't care. I need as much layout room underneath this board as possible, and so we can ignore these. I mean, these are kind of cool that they've got these like fairly prominent mounting holes. You can use pan head laptop screws in order to mount this thing and make it look pretty nice if you need to. You know, if you're doing like a cosplay that has a bunch of wires coming off of the RP2040, which boy, oh boy, I love seeing it. I love seeing people doing like, you know, like fursuits and cosplay outfits that incorporate like smoke and LED stuff and screens and all that stuff. Is like mind-boggling. I love it. The advent of powerful microcontrollers make that happen, and it's a beautiful thing. You love to see it. Let's see if I have pan head screws. You can see how cool they look in this thing. Did you draw this? All I did was figure out where the pads are. I got the model from GrabCAD. GrabCAD is a manufacturing, well, GrabCAD used to be a database of people's public designs in, you know, whatever CAD program they're using. Typically it's Fusion for GrabCAD. There's a lot of Fusion stuff in there, and people will submit their designs so that other people can have access to them, and it saves me a lot of time. Saves me a lot of time. Looks like my pan heads are too big. Don't quite cleanly fit in those little recesses. So I'd have to find different panhead screws. Every board I design includes smoke. That's okay. So there's intentional smoke, and then there's whatever the hell's going on there. Look, anything can be a fusible link if you try hard enough. All right, so we've got the footprint now for the CAD model that we got. Somebody else decided to get all the proper measurements in. I've done it before where I've made like a little proto module like this and made it as close as possible. It's also, there's a possibility, why is that one split? What in the world? There's a possibility that Raspberry Pi has a 3D model somewhere that we could access publicly. I don't know what they did in order to get this logo on here. This is really clean. But this is basically just something that I downloaded on the internet. And so a lot of manufacturers, like if you're using a particular part, a lot of manufacturers will actually include a 3D model of their part. Like this could potentially have come from a manufacturer. Could have potentially come from a manufacturer. Still an orthographic view? No, perspective with ortho faces. Just delete the split line. I don't want to mess with the model. I don't think this'll. Yeah, it doesn't let me do that. They're two separate things. What we're doing right now is the pad layout. We're just putting pads on everything. Specifically. So, okay, so double checked it. Everything looks good. All of our pads are where they should be. I'm going to hit finish. Now we have the arduous task of creating an actual symbol to represent this. This is what goes down on the silicon. So on the silk screen and the keep out layers and the pads and everything like that, we've got everything sort of sorted out here. Now we need a symbol that's going to tell the CAD program what pins are what. So that's another big piece of work that we need to get through. The RP2040 is not short on pins. So I'm going to go here and make a new one, and it's going to be Pico Pi. And what else about this thing? I guess it's just the regular old Pico Pi. We'll just call it Pico Pi. I can rename it if I need to. Oh boy, here I go. So we're going to start on the symbols layer. I mean, technically it would be a module, but I don't really use the module layer. So we're going to start with just the symbol. And the symbol is going to be a massive square. Just like us. Let me just double check on that. There, I'm just going to do that and hit save. We'll just knock into this one and just check. Yeah, it is on the symbols layer. Why am I drawing this on the piss layer? Why does it have to be piss color? Okay, so we need a Raspberry Pi Pico pinout. We got a nice name of all of the pins here. Oh, okay. I guess I'll stick with a GPIO name. Yeah, we'll stick with GPIO name. Run! All right, here we go. Here I go, naming pins. So where do we want these? So I want to have, we'll have both names, I suppose. Name and function. And then we'll have short pins. Just like that. And let's see, I'm going to do, well, let me just go around the perimeter and just do them like this. And we can restructure them once they're all down. Four, five, six, 7, 8, 9, 10, 11, 12, 13, 14. Oh my God. 15, 16, 17, 18, 19, 20. On the other side here. 1, 2. Oops, wait, hold on. Wait, did it switch to long pin? No, it's still in the short ones. Weird. It's so many pins. Seven, 38, 39, 40. All right, so pin 1, GP0. GP0. What else do we have? Function, visible both, angle, size. Now this can help you, but direction can also help it sometimes. Like you can set specific ones to be power. This one is a GP0, so it is actually just an IO. So click OK on that one. This one's GP1. This one would be ground. So I can actually change this one to be power. What do we have? Power, pass, his, sup, in, out, no connect. So power, and this would be ground. GP2, we just got to go through all these. Unless somebody already made like a Fusion 360 model for this, but naming pins is dangerous, bother. They are the same length and grid blocks. What? Yeah, they seem like the longer ones to me, but this is weird. Why are they all IO0? Is that swap level, I guess? GP3. These big microcontroller platforms are all always like this. And we can kind of split it up and rearrange it a little bit to make more sense. Oops, that would be GP5. Pin 8 is another ground. The name ground already exists. So I'm just going to do, this one will do ground 3. I'll name it with the pin. So ground 3 and the other one's ground 8. Pin 9, GP6. Oh my God, this is going to take forever. Sorry, everybody. This is just the work. Now, when I actually do get to throw this into the schematic, we can then go to the actual board itself, and I can start shaping the outer edge of what's going to be the flexi-pcb. Yeah, well, this microcontroller platform was specifically made to accommodate quite a bit of I/O. It's not enough for our keyboard. It's not enough. I would have had it go completely on the RP2040, but I had to use the muxes in order to lower the number of overall pins. Yeah, all ground pins are just connected to ground potential. It's if you look at the board itself, you can see the little square. Let me get the pointer and the light. My light's all the way over here. My light is all the way over there. Yes, so if you look, the little square-headed amogus are all the ground pins. Actually, some of them aren't square-headed. Why are some of these squares then? This one is a ground, this one is a ground. What it's doing is it's going out to this ground plane. And that ground plane, at least not on this layer, but the ground plane is going to connect to a much larger series of copper pores that will take it all over the place and eventually back to the same source. So These staple your board together and hold all the grounds in place and keep from allowing noise into your circuit. They disallow, they don't allow, they disavow, whatever. Anyway, the point is all this poor stuff is just to kind of help with, you know, keeping a ground plane established on the whole board. And having a big ground plane means you can also dump heat into it, which is what's going on here. These are vias that are attaching the top and the bottom ground plane electrically, but then also thermally. So heat will travel down from the chip to this big open plane and dissipate throughout the rest of this thing. The Raspberry Pi people are very good about heat dissipation. They appreciate a good ground pour, as do I, although this is a little clunky right here. But they love a good ground pour. I love a good ground pour. And what happens when you do that is you get really good heat dissipation. The Raspberry Pi products, you can see when they heat up, the entire board heats up uniformly. It's very cool to see. It appears as though this one does not. They kept it stupid simple. They kept it nice and stupid simple so that you didn't have to worry about it. And I do appreciate them not having the faff. Making just a nice simple microcontroller. Pin 11, I've lost my window. GP8. Oh boy, this is the stuff I should have done. I expected us to be doing like a weird PCB right now, and I always get ahead of myself in my expectations. So we'll have to figure out. You know, some of the other parts are going to be the other microcontroller. We're going to have to somehow map a component that's a bunch of pins on a bunch of exposed pads on the edges, basically in the middle of the rows of pins for this microcontroller. That'll solder flat down onto there when I remove some of these components. That's going to be a weird one. They did as many as they needed, as many as would make sense. If you ever seen a Raspberry Pi under a thermal camera, you can see how it dissipates heat. It's brilliant at it. It's actually very good at it. PS12, pin 12 is GP9. GP9, go! Oh, P9. Wait, what happened to P9? GP6. Oh, I'm off! This one is supposed to be GP6. This one is GP7. Oh my god, such a flagrant error. The dog's just barking at the door. Six, seven, eight, nine, ground. This would be ground 13. Oh wow, that's lucky. I don't need you guys to tell me when I'm doing something wrong. Part of the stream is making mistakes and correcting the mistakes. If you never make a mistake, you're not going to know what you're doing when you're faced with correcting one. Why? Ooh, whoa. Make it kind of girthy. Make it look big. Pin 14. GP10. Oh my god, people must be walking their dogs right now. Father makes a mistake because, oh wait, why is my window covering that over? Hold on. Yeah. Even bother is only human after all. That's right. Human, 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 human. GP11. Welcome to my pin naming stream where I name pins. Today we're going to name GP12. Thanks for watching my pin naming stream. Pin 17 is GP13. I may just leave these on the sides the way they are, just because there are so many pins that this thing has. If I move all the grounds over to a block, I'm still going to be faced with all these general purpose pins all over the place, and we might as well just keep it true to what the Raspberry Pi Pico actually has. So this would be Pin 18 is another GND. GND 18. Yeah, unfortunately, sometimes when you do engineering like this, it just becomes work. It's just work. So we need to get this work done before we get cool designs coming in. Okay, jumping over to the other side. This one's GP16. It's going to be really cool to make this board, though. It's going to be really cool. Purpose 17. This one's ground 23. What's next? Oh, more GP. GP 18. That's why I use the board, because it's got a lot of stuff. In 25. GP 19. 26. GP 20. It's best not to rush these things too. You make mistakes, and these are, if I make a mistake here, it's going to trickle through to the entire design, and then I'll get the PCB made, and I'll look at it and I'll go, oh, I made a mistake there. So it's good to be a little bit ponderously slow here. 27, GP 21. Get a big pot of coffee. Wait, pin 27 is GP 21. Why is GP 20? Oh, it was auto-filling it for me. That's what I'm talking about. So if I go to this one, pin 28 is ground 28. Hold on, GND 28. But what this will do is it'll look at the titles of the pins and it'll increment it. So pin 29 is GP 22. So if I go GP and the last one was 21, it's going to suggest 22. You can see right there, it just suggested it for me. So that helps a little bit, although if you're not paying attention, it can kind of mess things up. This one is simply titled Run. Run! Now, can the run pin initiate programming? Is this just the boot select button? I don't think it is. I don't think run is boot select. Another one of the little proclivities of the RP2040. So the pin that I'm talking about is pin 30, which is in a nice central location to this entire thing. So we have to go 40, 39, 38. 30. Actually, wait, are these? Oh, here we go. Run. Goes in, goes to a via right here. Via right here. Goes out and around, for some reason, way around the processor, and goes to a via here, which goes into the board on this pin. So it's a separate function from boot select, which is coming over to here to a resistor. And who knows? That's been removed. Whoa! There's this giant trace here. I don't know what that's doing. It's the enable pin? Okay. So it is not, yeah, it's not something that I can route to the boot select button, which I have to route to a specific location on the back of the keyboard so that you can reach in and push that button and make it a reprogram. Run is different. P31, pin 31, GP26. GP. What? Oh yeah, jumps a couple. GP26, huh? These have not been assigned pads yet, by the way. 32 is GP27. It still wants me to make 23, but we're up to 27 now. 27, 33 is ground. It's its own unique little ground name. GND 33. So, by the way, I had a pretty decent holiday season. Of course, I've got tons of credit card debt to pay off, but still, I had a pretty decent holiday season. I got a 3D scanner. So we're going to be able to like do some 3D scanning stuff and actually pull that into AutoCAD and make potentially an airbag cover for my steering wheel project, among other things, amogus other things. We can probably figure out a bunch of other stuff that we could use that 3D scanner for, and we'll see how effective it is. It's the Creality one. It's that $300-ish Creality one. Yeah, it was a big holiday buy. Hopefully it'll be worth it. I think it will be for the amount of physical stuff that we mess around with around here. It requires a lot of little dots to go on stuff, and I have chalk spray that you can use to kind of make it a monochrome affair. But we'll see how it is. I've also got a turntable and stuff, so we can have some fun with that. We'll hopefully be able to use it for some interesting stuff. Yeah, new toys should breathe a little bit of life into this stream where I'm simply naming pins. So that gets here tomorrow, so I might not stream tomorrow. I might work with the new thing tomorrow, or just wait for it to arrive. I don't know. I think there may not be a stream tomorrow, but I'll have to figure out what's going on. Next week, of course, we're going to have a totally normal week, except for, I don't know when New Year's is. I don't really have any New Year's plans this year. 35 it doesn't have a name? What? VREF. We'll call it VREF. VREF, do that. So 36 is going to be assigned power. What is it? IO, we go to power, and this one is 3v3 out. We're going to be using that pin. 37 is 3v3 enable. Let's put an underscore on that other one so it just matches the... Three v3 enable. Next one is ground 38. I'm only here for the pin naming streams. They're incredibly exciting, and I would urge everybody to take a little break, maybe, you know, move your arms and legs a little bit, just kind of calm down just a bit, because the heart rate can get pretty high when doing stuff like this. VSys is going to be that's a power again, and then VBus. VBus is going to be another power. So basically, VSys is if you have 3 volts to give to the thing. If you got 5 volts, you put it into VBus, that puts it through the regulator. 3v3 out is what's going to power all of our other components, which would just be a couple muxes. The pin naming streams are how all the other electrical engineering streamers become famous. Yeah, I remember the days of the sellout. They were some big sellouts out there, man. They had to be, they were like, I'm doing a pin naming stream, and everybody's like, ah. Chat's flying by, you can't see a goddamn thing. And call that's got a line over it. It's actually the opposite polarity. The enable's low. Streamer, listen to me. Just don't get to the end and find out you're off by 1. I've done that before, but when I was putting these down, it was giving them pin numbers. And so I was able to keep those pin numbers consistent and just look through this and match up the pin number to the function and just call it the same thing. Even though this will wipe the pin number now, it would be nice if I could relay them back and forth, but we're going to keep it looking like this just because this is the simplest form. Let me just do the name. So NAMEs, and then we go to our text and we do capital NAME. We'll just put that there, and then we do capital value. Put that below that, nice and clean. And that's what we're gonna do. It's gonna be RP or Pico Pi, et cetera, et cetera, et cetera. Can't wait for pin 26. Oh, it's gifted subs everywhere. Yeah, I mean, this is like minimalistic. This is a fairly Spartan symbol for this. It does help to kind of distribute the pins around and get the functions in the right spots. I'm going to leave this the way it is just because we're trying to move on from this crap. So, yeah, only one ground. It's V-Bus. Wait, what are you talking about? One ground. There's tons of grounds. This thing is like all grounds. But the whatever it is, the power comes in through bus, which would be the 5 volts from USB, sys, which is if you want to bypass the internal regulator. Then you have enabling for the internal regulator, I guess, and then 3V3 out, which is if you want to power other accessories, which is what we'll be doing. Oh yeah, I didn't label the other ones as power. I don't know if it's going to matter that much, but I guess I'll correct that. I think it's just when it checks over your design, it that has some weight to it. Or if it's like auto routing, maybe. But I don't really trust the auto router. The only auto router that I trust is Topor. Also, some of these like enable pins are probably not I/O. They're probably ins. Like run, I don't know what that is. That may be I/O. Auto routers are the devil. Well, the king of auto routers is Topor. Okay, there we go. All right. Save on that. Click OK. We can finally make the Pico Pi as a part. Oh my God. Raspberry Pi Pico 2020. I don't know what else to call it, how to identify it. It's not a Pico 2, it's an original Pico. I guess the pinout I was looking at was for the Pico 2, but I think they have the same pinout. No, it's not called the RP2040. The RP2040 is the chip. That's the chip. I know this thing is basically the chip that it rides on, but when you say Raspberry Pi Pico, you mean this board, not just that chip. It is implied that it is the RP2040, but yeah. You're doing a great stream. It's a little boring, and I hope my voice and all the stupid shit that I'm talking about can hopefully carry me through a little bit and keep you guys from getting completely like bored to tears. I mean, if I just call it RPi Pico 2020, that's fine. The Raspberry Pi 2 has a different title. I think we're fine with the title that I put down. I think it's okay. Picos are awesome. I've done a fairly limited number of little projects with it, but from what I've used, I've really enjoyed it. The RP2040 in general, the Seed Studio Zhao is what I've used for modular synthesizer. I don't know where that board went. For modular synthesizer stuff, it's got a more limited pinout when you don't need a whole lot of I/O. It's a great little board because, I mean, geez, these things cost like $1. It's amazing. The actual chip itself is $1. This is $5, which I'm totally willing to put into a project because this thing can run like MicroPython. It can run all kinds of stuff. And look at how many Amogus it has. It has all the Amogus. But yeah, that's pretty crazy chip. This was Twisted Sister, who's like an IRL friend of mine, was like, you got to buy these now. You got to buy these now. You got to buy these now. And it was right in 2020 when the chip scarcity started to really sink in. And so I ordered about like 10 of them for a couple bucks each and ended up getting them right in the middle of the pandemic. But I haven't had a lot of uses for these yet. There's a ton of I/O on it, and it's a nice, cheap little chip. As much as I would love to put the chip down bare onto the circuit board, I really don't want to deal with all of the annoyances of trying to get such a fine pin pitch soldered properly. I can do it, I just don't want to. So we're putting down the whole, we are firing the whole bullet. That's more bullet for your bullet. We're using the whole thing, and it's going to be stashed either up here or somewhere nearby. I don't really like putting it so far down on the keyboard because this is where water is going to pool. So if we keep it up here, it'll be relatively safe from my debauchery. I think that's probably going to be the plan. What about the reprogrammable I/O interface? I don't understand that. Being able to press the button and reprogram it on boot, I guess. I'm really amazed at how much a single IC can do these days, but at the same time, I want to cry because I've missed an era of analog hobbyist stuff by 20 years. There was a ThinkPad that I used to have from God knows what era. It was probably from the early 2000s. And boy, oh boy, you could look at this PCB and you can look at the chips and you can look up the numbers for the chips. And there are data sheets for the chips, and the data sheets for the chips tell you what the chips do. One of the ICs was actually designed to measure multiple different temperatures, but not with thermometers. It used diodes, just straight up diodes. And it was all in the data sheet for me to learn about. Whoa, I didn't know you could do that. You could just use a diode as a thermometer. And this was a chip that did that for multiple different things, and you could speak to it with I2C. It was full of stuff like that. I don't remember what happened to that circuit board. I was taking chips off of it for a long time. It was one of my sacrificial boards at the bottom here that I keep under the desk in the kick bin. But man, that thing was awesome. It really did a good job. I think because it's the holiday season, my next stream is going to be on Tuesday. I got to do it. Is Tuesday New Year's? Tuesday is the 31st. That's a perfect time. Yeah, that'll be great. So the next stream is going to be on the 31st. I got to do it. I need another weekend to kind of get used to things here, and maybe we can pull some of these projects up out of the crapper a little bit. It's like a firmware section that lets you format and map bit streams to the CPU. Oh, so the CPU doesn't have to do it. That's that little like FPGA style section of it, right? I haven't gotten a chance to utilize that yet. I think that would be very cool. I wonder if I could do something like that with sound. RP2040s have a programmable input-output system for its pins, which has its own language. It's really powerful. Huh. Okay, so Raspberry Pico 2020 is what I'm going to call that. And we have nothing. We have nothing. All the work that we did is gone. Now, what we're going to do is we're going to plant down our schematic symbol. So that's going to be Pico Pi. I'm going to put that. It's a little bit compact. It's going to be kind of hellish. And then this is renaming it to G1. What I can do is I can go to properties and I can just call it U1 here. That is just going to be for this view. Down here on the prefix, I'm going to give that a U. And then new, add local package. And so here's all of our package pinouts. Picopi. And the variant name is going to be SMD. And now it's got a 3D model, it's got pads, and it has pins, but it does not know what pins are connected to what. You can implement I2S with PIO on the Pico Pi. Jeez, I can't even imagine operating at that level. I can't even imagine. It's fine that I usually need to fix a buttload of stuff on the footprints I get from Mauser before using them. Is it just accepted in the industry? That's what you get when you default is usually ass. I don't trust another person to give me footprints. I got the SparkFun library and I got the, what do you call it? The Seed Studio library because the resistors were a little better. And then I modified them for my own purposes. Your best parts are the parts you've used in a design before. And so I try to follow that mantra. Fusion 360 is really good with measurements and stuff. As you saw, what we were doing is we were taking somebody's 3D model and we were measuring them and we were comparing them to what I get with the calipers. These things are your friends. Do not skimp on calipers. Buy the $150 calipers. They'll last longer. They'll give you better measurements. And with the level of precision that we're used to dealing with electronics, you want to have good measurement tools and know how to use them. It's very, very important when you're putting together a circuit board, because fundamentally this is a mechanical design that we are using different manufacturing techniques than your typical milling machine to put together. We're not doing things quite that way. We're not 3D printing it, we're not milling it, we're etching it, but our precision level is through the roof. And so you want to meet that with your own tools. Get good calipers. And that way you can verify this thing is 21 from end to end, 20.99. Basically 21. And if I wiggle it a little bit, it becomes 21. Look at that. Beautiful precision. Verify, check, don't trust. Correcting, because so listen, I come from an era before, well before, oops, what is that? What are we looking at? My absolute hole. I come from an era where a PCB was $100 and you waited a month for it. And you would get something without a solder mask on it. And you would solder your stuff down. And sometimes something wouldn't fit. It's another month. It's another $100. You can print. And Fusion does this too, and all the programs in the past have done that. I can get Control P. And I can print on an 8.5 by 11 sheet of paper a relatively, very accurate layout. I can print the solder mask layer. And I can see if every solder mask and pads, I can print out onto a sheet of paper, and I can lay my components out on that and see if it's the right size, see if everything's just perfect. You just use metric. I only use metric. Yeah, I don't really like jumping into inches. I understand inches from a realistic perspective because I've been, oh wait, where's the camera? I've always been working in inches as an American. The human understandable units for me are the American style units, but when it comes down to brass tacks, I am measuring in metric. You need to do both as an electronics person. You need to be able to do both because the old standards for spacing and sizing that you're going to use in the prototyping stage, that's inch, baby. Those are 1.27 or whatever. These are 0.1 of an inch spaced hulls. So you're going to need to be able to work in that. But then if you swap over to surface mount, this stuff is all metric. So you got to be able to just be a worldly gentleman of many measurements. Put on your top hat and cane, spin it around, and say bully a lot. I guess I don't know how upper class works. Anyway, okay, so we've got our schematic symbol, we have our footprints, we have our 3D model, but the CAD program can't make heads or tails of that. So we go to connect, and now we have to connect all of these functional pins to all of the pin numbers. And this thing is taken on itself, on its own, it's taken to just renaming them based on the names, not on the pin numbers that they originally were. So I'm going to first start out with the ones that are easy. Ground 3 is pin 3. Boop, and I connect. So the thing is, like, giving them all their own pins is one thing. I guess I'm going to just have to connect them on my own to the same thing, because you can append, like I could have a ground pin and I could have one single ground, and then I could associate it with all those subsequent pins and just have this one pin that's all the grounds. I kept them separate. I guess it's not really going to matter all that much. I'll just end up connecting them all to the same ground pin. Brass tacks and metric only. I prefer metric generally, but got to use both. Well, who's using brass anymore? I guess I'm just going to keep them separate. They're separate but the same. They're all still grounds. Pin 13, pin 18, 23, 28, 33, and then 38. All right, 3.3 volt enable. So here's where I go and grab the other picture and I put it on the other monitor. Having multiple monitors is like a must when you're doing stuff like this. Did you ever learn Morse code? No, and I really meant to. I really wanted to learn Morse code. I'm terrible at memorization, but I am several decades old at this point. I could learn it. I should. I just haven't sat down and dedicated time to it. 3v3 enable is pin 37. 37. 3v3 out, pin 36. GP0 is pin 1. This may go a lot smoother. GP0 is pin 1. GP1, pin 2. GP2, pin 4. So what it's doing is we're just going down the list, and it happens to line up because I've already assigned all the grounds. Oh, yeah, that's just going to cover it over. I'll just put it on the other monitor. Ah! Get out of my face! GP3, pin 5. Correct. GP4. Pin 6. Correct. GP5. 7. 6, 9. Nice. 7, 10. Correct. 8, 11. Correct. 9, 12. Correct. 10, 14. Go. 11, 15. Go. 12, 16. Go. 13, 17. Go. Oh, this is nice. I could probably just bounce my finger on this button here. 14, 19. 15, 20. Okay. 21, 16. Correct. 17, 22. 18, 24. 19, 25. 26, 20. 27, 21. 29, 22. 31, 26. 32, 27. 28, 34. Run! And then I just start running. Run is on 30. Vabus, 39. Vref. Where's VREF? Oh, ADC VREF, 35. And the sys is 40. Whew, okay. So now our CAD program knows that when I put that block down and I put a wire from one pin of this thing to like a pad on a resistor, it knows physically which pad on the symbol or on the board layout, on the 3D symbol, all that stuff it's able to associate with each other. And it's able to actually give us this part properly. Control S the crap out of this, and let's make sure to get this up onto the cloud. Up you go into library IO. Disk drive mounts equals usually 440, 632. Oh yeah, it's very annoying, those computer sizes. I don't know why they decided on what they decided on. Yeah, there's a lot of English and there's a lot of metric in computers. They're from around the same era. Yeah, something that's been around for a long time is going to generally exist in a space in between metric and imperial. It's very annoying, and many Americans, much like myself, wish that we could get away from the English system. I do wish we could go metric. But when I talk about 30 miles an hour, I know how that feels. So, you know, in 32 degrees Fahrenheit, I know how that feels. We're not calibrated to these other measurement systems. That's not to say we couldn't change, but apparently all of our parents tried in the 70s and they decided, fuck it, and threw out so many years of potential progress. Okay, so our library has the part. Now, just to show you guys, let's jump into our design again. Remember we were designing a schematic? Remember that? So what I'm going to do is place components, and I'm going to make sure that I'm only viewing the ones that are in use. Oh, wait, I want, yeah, only in use. And then we're going to go to schematic managed, and I'm going to drop a frame letter down on this thing. The frame letter is there just to help you deal with the existential dread of the void. Where am I? Who am I? Why would a just God put me in this position? What's running all of this? What is the purpose of life? Where are your hands? This frame letter grounds you, and you go, oh, okay, it's an 8.5 by 11 sheet of paper. I am not a conscious mind in an indifferent universe. So anyway, we got our page down and we know to stick to our page. Now we can jump back and we can go to modules, and I can drop in the Raspberry Pi Pico 2020 SMD version. And there it is. It's going to take up a hell of a lot of space to put in there, but Raspberry Pi Pico 2020 SMD. Okay, I got to work a little better with these naming conventions. But so there's that. What I can now do is jump over to the 2D design. And in the 2D design, yep. Oh yeah, this we don't need, all the Creative Commons thing. But I've got my pads and layout for this thing. And let's make sure that our board is 100 by 100. So it gives you 100 by 160. 100 by 100 is going to be our base, and we're going to work from there. We're going to make some truly cursed components for this thing. But so there's that. Now we can actually go to generate a PCB. But the question is, how do we make it do a 2D flex PCB? I'm not sure I know how. Hold on one second. I'll have to look that up. Because I don't know if we can make it actually produce a 3D model of an orange flexi PCB. I think it's possible. I think we just have to specify some stuff where it makes the three-dimensional model. Like, there's like a manufacturing tab. Yeah, here we go. Export Gerber, OBD++, CAM processor, and CAM preview. Under CAM preview, we can actually change our board color and stuff. But I'm not sure if we have area, width, height, stack up, components, and copper layers. See, this is where we would edit this stuff. But I'm not sure if there's like a preview or something that we could actually use in order to create the 3D model. Because if I just make this right now, it's going to create an FR4 PCB. But I can show, I mean, this shows off the 3D capabilities of AutoCAD. We have an actual pad that has dimensions, so I probably should lift this up off the board just a little bit. But our pads overlap by 0.75 of a millimeter, so they will be moderately solderable and also minimalistic. And I should probably lift this up just a tiny little bit from the baseboard so that it just has a little bit of clearance off of the bottom. But anyway, that's how that's going to go down. And there's the solder mask layer. And we'll have to figure out the shaping tools and stuff like that. Just edit the board thickness. Yeah, I think I can edit the board thickness and then change the color scheme. So area, bod, width, height. That's not it. Copper layers 2. Board thickness. So how thick is the FR? Not the FR4. The GLC PCB stuff. Where can I find out more about it? Just accept. All right. Yeah, they're having a sale. It's $2 for 100 by 100 millimeter flexible PCB. What the heck? Where are our specifications? God, there's so much. When you go to a new manufacturer, there's so much that you have to learn. Did that look like I was at all finalizing the layout in any way, shape, or form? This is so early on in the process. But no, I don't need to access that the port there, because we're going to actually attach wires to the thing. The Pico Pi doesn't really give you good provisions for running out the pins. I think one of two things can happen here. I could leave open vias on the test points and solder them from the other side, or I can do what I did in this one, and I can just run a wire, just solder a wire to the top part and have it run out to where it needs to go. But I think for this design, I kind of want to avoid bodge wires. So I may use these test points. I think it would be very interesting to add just a little via right on top of the test point that's wide enough that I can get solder in there. 0.11, where'd you find that? Oh, the flexible, yeah, there we go. Thank you. Thank you, Ben Gizmo. Appreciate that. Oops, I gotta add an H to it because I didn't highlight it properly. Dude. I've been a little inundated lately. I didn't have my ADHD meds for like an entire month. And so I had not done my homework, which is, you know, hey, ADHD meds and doing your homework. It's like chocolate and peanut butter, two things I like. But yeah, anyway, I've sat at my computer with my mind a complete blank going, I should get something done. It's hell. It's hell. I hate ADHD. I hate every minute of it. And my meds make me into a normal person who can actually do work. It's kind of amazing. Flexible PCB. Flex and fit in compact spaces made for flexible materials like polyamide. Flex PCBs are used in applications where space is limited and flexibility is essential, such as wearable devices. Okay, anyway, silk screen, polyamide, DITFA, adhesive 15U, copper, 12U, polyamide, DK325. So the total thickness is 104 micrometers. Standard 0.11 millimeter two-layer flex PCB. A carefully structured stack. I've been called that before. Okay, so 0.11 millimeter. Oh no, cancel. I want this one. And we change the board thickness. Oh, do I not get to do that here? I guess I got to do it in settings here. I wonder if I can find like a preset that I could load for the cam job. Oh no, that's not right. That's not what I want. Yeah, we don't want the cam processor. We're looking at like board thickness for the cam preview. I just don't get why I can't change that number. Oh, because this is where you do it. Yeah. Background color, copper color, substrate color, default colors. So I think there's somewhere else that I actually have to specify that. So where is my board thickness? Those are the layers. That's the Gerber, drill, assembly, bill of material. That's not right. We're not doing that. Drill, auto drill. Top copper. We got all our, it's all like laying out high quality images. Huh. I'll have to learn where this is. Because my understanding was that this manufacturing preview was where we would be editing stuff like that. Because here, high quality, normal, or fast rendering. You can choose the background color, copper, screen, etc. And it'll change the color of the board. But then board thickness is over here, and I can't really mess with it. It doesn't allow me any editing. This just shows me what it is. Layers, board shape. These shaping tools we're gonna be using on this. Routing tools, shortcuts, and select. None of this is like the preferences, design preferences. No, this is other stuff. Yeah, so I loaded the JLC PCB design rules. I don't know if that's a modern document or not. Let's see. Here it is, 1.5 millimeter dielectric. So then this would become Where can I edit that? There we go. Edit material properties. There it is. So 0.11 millimeter. That's the overall. So it's going to be placing stuff on top of that. So it's going to look a little weird. I'm not going to go in and exhaustively edit all the values. But now if I switch to the PCB, I can hit push, and it's going to have this incredibly tiny PCB layer. Yeah, to the point where the grid is actually showing through. But so that's what essentially we'll do if we need to preview it. For all intents and purposes, this is just cosmetic, so I probably should put it back to what it was at before. I don't know if I can Control Z my way through that, though. What was that number before? Oh, great. Now I got to go in and look at the board thickness and 1.27. Oh, 1.5. Okay. Yeah, we're just going to go back to 1.5 for now until we get sort of a more finalized design of this thing. I should probably save it as its own specific cam job, too. The JLC PCB orange flexi. Because I can see this being useful in the future. I can see this being pretty useful in the future. Being able to do like an orange flexi PCB instead of like a wiring harness. Although, to be fair, I mean, we're pretty Bush League, but if the orange flexi PCB is $2, like, do that instead of having a big nest of wires inside of your device. All right, that's it for me. This is overtime. We've gone into overtime. I just tried to make the render look a little bit better. I can do some more work on that on my own. I'm not coming back tomorrow because it's the weekend and I need a little bit of more time to sort myself out. I didn't stream much this month because of the holiday, basically. But yeah, tomorrow is a cleanup day to try to pick up all the pieces of my life now that I have my medications. So we will break for that time. In the meantime, I will be on Discord. I'm always on the Discord. Keep temptation to see Discord is so strong. And hopefully I'm going to get a little bit more into some of these designs that we're doing. We got two things burning hot right now. One is this keyboard that I'd really like to revamp. The other one is, of course, the modular synthesizer thing and these very, very tiny, cramped designs. We're going to be doing more AutoCAD, more of my free copy of AutoCAD infecting the stream and making me a shill to corporate interests. But it's a good thing because it's a very mutual kind of thing. They get me talking about Fusion, and I get the software basically for doing nothing. This is what I do anyway. So thank you guys for joining me. I really appreciate you guys like stomaching this and following along and learning something new because that's really what it's all about. Where is my Twitch window? Where is that? It's way over here. I haven't been able to see anything. I am now an Autodesk shill. So I thanked everybody, right? Yeah, everybody is one sub for the whole stream. That's all right. That's all right. We got a lot of people here. I will see you guys on Tuesday, unless something crazy goes on Sunday and I decide to stream, but I don't think that's going to be the case. I think I'm going to work on this stuff on my own, and you guys will see incredible progress. One of the things that I meant to go over today, by the way, is a real quick thing. When you first start building a PCB, it's overwhelming. You've got all these parts in there. You put your schematic down. All these parts are just smashed into the side of the drawing. What you can do in Fusion is highlight the part of the schematic that you would like to build. Highlight it, and then when you flip over to the two-dimensional board, it highlights all those components. Grab them, move them over, and then rearrange them until those little air wires that are connecting things get clean. So you clean up those air wires, move all your functional blocks together, then you can start to move them onto the two-dimensional PCB and route all the traces, you know, function by function by function. You do power last because power can sort of wiggle around all of your other signals. And you can unview those air wires. You can actually select them to be hidden. Functional groups get blocked together, move those over to the board one by one, start really smashing your design together. Then you make it pretty. And then you get a meme and you put a meme on it and you hit order and boards are on your doorstep for super cheap. So anyway, we're going to be doing that on Tuesday, and hopefully I'll make a little bit of progress going there. Yeah, component placement is a very useful skill. It's something that you can force or you could get very, very creative. And for me, it's usually something that I have to power through. And once you start the ball rolling, everything kind of falls in line. Many problems suddenly boil down to a few. It's a really cool process. I want to bring you guys along with me on that for these designs. Or if you're like me, you just throw them on and pray hard. Yeah, some people throw them on and they just do an auto router and they just trust the auto router. I don't understand that at all. For me, it's an artwork, so I need to like go in there and place things and make sure everything is just right. It's a tough thing. Hey, wonky robot, I'm actually just wrapping up. Save me, auto router. That ain't me. That ain't me. Oh, we need to turn chat on here. Okay. All right. I will catch you guys later. Thank you for joining me on the stream.